The night sky has always held secrets. For millennia, humans have gazed upward, charting the movements of celestial bodies with increasing precision, finding comfort in their predictability. Stars wheeled overhead in their ancient dance. Planets traced their wandering paths. Comets appeared and disappeared on schedules we learned to anticipate. The universe, for all its vastness, seemed to follow rules we could understand. Then, something arrived that broke those rules. On September 1, 2019, Gennady Borisov, an amateur astronomer working at his personal observatory in Crimea, noticed something unusual through his telescope. It was moving. That alone wasn't remarkable. The solar system is full of moving objects. But this one was moving wrong. Its trajectory was all wrong. The calculations were impossible to reconcile with anything that belonged to our cosmic neighborhood. Borisov had discovered only the second interstellar object ever detected passing through our solar system. The first, Oumuamua, had already departed by the time astronomers realized what it was, leaving behind more questions than answers. But this new visitor, initially designated C2019Q4 and later renamed 2I Borisov, gave the scientific community something they desperately wanted: time. Time to study it, time to understand it, time to point every available telescope at an actual visitor from another star system. Except 2I Borisov, despite its exotic origin, behaved exactly as a comet should. It outgassed, it developed a coma and tail, it followed the laws of physics with tedious predictability. Scientists were thrilled to study it, of course, but there was an undercurrent of disappointment. Here was an object from another solar system, and it looked and acted just like our own comets. The universe, it seemed, lacked imagination. Then came 3I Atlas. The detection happened on April 7, 2024, at the Asteroid Terrestrial Impact Last Alert System facility in Hawaii. The automated survey telescope, designed to scan the sky for potentially hazardous asteroids, flagged an object with an anomalous trajectory. Within hours, observatories around the world were scrambling to confirm what the preliminary data suggested. This was the third interstellar object ever detected, and it was still inbound, approaching the inner solar system at a relative velocity of approximately 87 kilometers per second. That velocity alone was extraordinary. Oumuamua had been traveling at about 26 kilometers per second relative to the Sun. 2I Borisov clocked in at roughly 32 kilometers per second, but 3I Atlas was moving nearly 3 times faster than the first interstellar visitor. It was screaming through space at a speed that suggested a violent origin or an impossibly long journey from somewhere very, very far away. Dr. Sarah Chen, an astrophysicist at the Harvard-Smithsonian Center for Astrophysics, was among the first to access the preliminary data. She remembers the moment with crystalline clarity. "I saw the velocity estimate and thought it had to be wrong," she recalls. "I spent 2 hours checking and rechecking the calculations. When I finally accepted that the numbers were correct, I felt this wave of excitement and unease. Something traveling that fast from interstellar space would have to have an extraordinary story. We just had no idea how extraordinary." The object was small, at least by cosmic standards. Initial estimates based on its brightness and albedo suggested a diameter somewhere between 400 and 800 meters. Not large enough to be a planet or dwarf planet, but substantial enough to be interesting. Its spectroscopic signature was confusing from the start. Unlike 2I Borisov, which had shown clear signs of cometary composition, water ice, carbon dioxide, carbon monoxide, 3I Atlas reflected light in ways that didn't match any known category of solar system object. It wasn't quite like an asteroid, Chen explains, but it wasn't like a comet either. The spectral lines suggested metals, iron, nickel, perhaps titanium, but in ratios we don't see in natural objects. And there were these absorption features we couldn't identify at all. It was like looking at a periodic table that had been shuffled. The astronomical community mobilized with unprecedented speed. Observing time on the world's most powerful telescopes was reassigned. Radio telescopes were pointed at the visitor. Space-based observatories adjusted their schedules. Everyone wanted data on 3I Atlas before it made its closest approach to the Sun and potentially became too bright to observe safely. Or worse, broke apart from thermal stress. The first truly alarming data came from the Very Large Telescope in Chile on April 15, 2024. A team led by Dr. Ramon Vega had obtained high-resolution spectroscopic observations over a 6-hour period. When he examined the results, he noticed something that made him call an emergency meeting with his colleagues. The object was changing. Not in the way comets change as they approach the sun. That would have been expected and understood. 3I Atlas was changing in discrete steps. Every 47 minutes, like clockwork, its spectroscopic signature would shift. Certain absorption lines would strengthen while others faded. The overall brightness would fluctuate by approximately 0.3 magnitudes. And most puzzling of all, the object appeared to be changing shape. At first, we thought it was rotation, Vega explains. Many asteroids are irregular and appear to change brightness as they tumble through space, presenting different surface areas to our telescopes. But the pattern was too regular, too precise. And when we analyzed the polarimetry data, it became clear that the geometry of the object itself was actually changing, not rotating, changing. The implications were staggering. No natural process could account for an object that altered its physical structure with such regularity. Rotation is universal in space, even the most irregular tumbling. Asteroid maintains its shape, but 3I Atlas seemed to be transforming itself every 47 minutes as if it were breathing. The news leaked, as such things always do. By April 20, 2024, social media was ablaze with speculation about the shape-shifting asteroid. Mainstream news organizations picked up the story, though most treated it with appropriate scientific skepticism. The more sensational outlets, predictably, jumped immediately to the conclusion that astronomers were observing an alien spacecraft. The scientific community was more cautious, but no less intrigued. NASA convened a special panel to coordinate observations and share data. The European Space Agency did the same. Within days, every major observatory on Earth that could see 3I Atlas was looking at it. Space-based telescopes, freed from the blurring effects of Earth's atmosphere, provided even more detailed observations. And those observations only deepened the mystery. Dr. Kenji Yamamoto, working with data from the Hubble Space Telescope, discovered that 3I Atlas was emitting light in wavelengths that couldn't be explained by reflected sunlight alone. There was a faint but distinct luminescence in the infrared spectrum, pulsing with the same 47-minute period as the shape changes. It was radiating more energy than it was receiving from the sun, Yamamoto states flatly. That's not supposed to happen unless there's an internal heat source. But the temperature was wrong for radioactive decay. It was too uniform, too controlled. Whatever was generating that heat, it wasn't any natural radioactive process we know of. The object was also decelerating in ways that violated its expected trajectory. Without any visible outgassing, no comet tail, no coma, no jets of sublimating ice, 3I Atlas was somehow shedding velocity. The effect was subtle, only a few meters per second over several days, but it was measurable and undeniable. Something was providing thrust. Dr. Chen and her team published a preliminary paper on May 2024, carefully outlining the observations and avoiding sensational conclusions. But the final paragraph was impossible to miss. The observed characteristics of 3I Atlas are inconsistent with any known natural phenomena. While we are not prepared to speculate on the object's origin or nature, we must acknowledge that its behavior suggests the presence of active processes that cannot be explained by current models of cometary or asteroidal activity. Further observations are urgently needed. In the deliberately understated language of scientific papers, this was equivalent to screaming. Radio telescopes had been monitoring 3I Atlas since its discovery, searching for any signal that might indicate artificial origin. For the first 3 weeks, they detected nothing but the natural radio emissions expected from any rocky body in space. Faint, random, meaningless. Then, on April 28, 2024, the Very Large Array in New Mexico picked up something different. It was a narrow band. Signal at 1.42 gigahertz, the frequency of neutral hydrogen's emission line. Astronomers call this the water hole, the quiet zone in the radio spectrum where natural cosmic noise is minimal. It's also the frequency that SETI researchers have long theorized would be an obvious choice for interstellar communication. Any technological civilization would know about it. The signal lasted for 17 seconds. It repeated exactly 47 minutes later. Then again and again. Dr. Elena Petrov, the radio astronomer who first identified the signal, spent hours verifying that it wasn't terrestrial interference, a satellite reflection, or instrumental error. When she was certain of her results, she picked up her phone and made a call that would change everything. "I've found something," she said simply, "and I think you need to see it right now." Within hours, the signal had been confirmed by 3 other radio telescope facilities. It was real. It was coming from 3I Atlas, and it was definitely not natural. The pattern of the signal was maddeningly simple, yet frustratingly opaque. It consisted of a series of pulses, each lasting a fraction of a second, grouped in a specific pattern. 3 short, 2 long, 3 short, 2 long, repeated for the duration of each 17-second transmission. The gaps between pulses varied slightly, but the overall structure remained constant. Mathematicians, cryptographers, and linguists were brought in to analyze the pattern. Was it a message? A beacon? Random noise that only appeared structured? The debates raged for days. Some saw mathematical constants in the pulse timings. Others found prime numbers. Still others insisted it was pareidolia, humans finding patterns where none existed, seeing meaning in randomness because we desperately wanted meaning to exist. But the signal continued, regular as a heartbeat every 47 minutes. The world's attention was now fully focused on 3I Atlas. It dominated news cycles. Social media was flooded with theories ranging from sober scientific analysis to wild speculation about ancient alien civilizations and cosmic arcs. Religious leaders offered interpretations. Governments issued carefully worded statements. The United Nations convened an emergency session to discuss protocols for potential contact with non-human intelligence, dusting off decades-old documents that had been dismissed as theoretical exercises. On May 10, 2024, 3I Atlas crossed the orbit of Mars. It was now deep in the inner solar system, approaching the point of its closest pass to Earth, which would occur in mid-June. The object was bright enough now to be visible in amateur telescopes, and millions of people around the world pointed their instruments skyward to catch a glimpse of the mysterious visitor. And then, it did something that no one anticipated. Dr. Chen was at her desk at 3:47 a.m. Eastern Time when her phone began receiving urgent alerts from the automated monitoring system. She grabbed her laptop and pulled up the data. Stream, her exhaustion evaporating as she saw what was happening. 3I Atlas was splitting, not fragmenting, not breaking apart under thermal stress or tidal forces. It was dividing, cleanly and precisely, into 7 distinct pieces. Each piece maintained the same spectroscopic signature as the original. Each piece began emitting the same 1.42 GHz radio signal. And most remarkably, each piece was now moving on a slightly different trajectory, spreading out from the original path like fingers extending from a palm. The division took 47 minutes to complete. That's when we knew, Chen says, her voice quiet with the weight of memory. That's when we had to face what we'd been avoiding. This wasn't a natural object. This was something that was doing things, making decisions, changing itself, responding to its environment. We were watching something with agency. The 7 fragments, each between 50 and 150 meters in diameter based on revised estimates, began a complex gravitational dance. They weren't just drifting apart randomly, they were adjusting their velocities with precision, using tiny but measurable amounts of thrust to modify their trajectories. Within 3 days, they had arranged themselves in a geometric pattern, a perfect heptagon spanning approximately 200 kilometers from edge to edge, slowly rotating as it moved through space. Radio observatories detected that the signal had changed. Each fragment was now transmitting on a slightly different frequency, creating a 7-note chord in the radio spectrum. The pulses were synchronized, creating interference patterns that rippled across the receiver dishes like waves on a pond. Dr. Yamamoto's team made another discovery using Hubble's high-resolution imaging. The fragments weren't just broadcasting, they were also scanning. Each piece was emitting tight beam radar pulses, sweeping across the inner solar system in a methodical pattern. Whatever 3I Atlas was, it appeared to be mapping its surroundings. It reminded me of sonar, Yamamoto explains, like a dolphin clicking to build a picture of its environment, except this was happening on a cosmic scale, and the resolution was extraordinary. Based on the beam width and frequency, these radar pulses could probably detect objects smaller than a meter across within millions of kilometers. The fragments were looking at us, looking at Earth. On May 18, 2024, one of the radar beams swept directly across Earth, lingering for approximately 22 minutes before moving on to scan other regions of the inner solar system. During those minutes, every radio telescope on Earth recorded a complex series of pulses that seemed to be analyzing our planet's electromagnetic signature. Our radio transmissions, our satellites, our radar installations, everything we broadcast into space was being cataloged by whatever intelligence-guided 3I Atlas. The public reaction was predictable chaos. Some people celebrated, convinced that humanity was about to make first contact with a benevolent alien civilization. Others panicked, stocking up on supplies and preparing for invasion. Governments struggled to maintain order while simultaneously dealing with their own uncertainties. How do you prepare for something utterly unprecedented? What protocols exist for this? Scientists found themselves thrust into an uncomfortable spotlight, forced to provide answers to questions they'd barely begun to formulate. Conferences were organized with desperate speed. Papers were rushed through peer review, and everyone, from the most senior astrophysicist to the newest graduate student, understood that they were witnessing a moment that would define human history. Dr. Petrov and her team at the Very Large Array continued their vigil, monitoring the radio signals from the 7 fragments. On May 23, 2024, they detected a new transmission. This one was different, longer, more complex, and transmitted simultaneously from all 7 fragments in perfect synchronization. The signal lasted for 2 hours and 17 minutes. It contained approximately 47 gigabytes of information, encoded in a surprisingly straightforward binary format. The message, for it was clearly a message, included what appeared to be mathematical constants, chemical formulas, and something that might have been star charts or navigational data. And buried in the center of the transmission was something that caused heated debate among the scientists analyzing it: an image. It was constructed from simple black and white pixels, assembled line by line from the binary data. The resolution was low, only 3,600 by 3,600 pixels, but the content was unmistakable. It showed a planetary system, a star with multiple orbiting bodies. One of them, highlighted in a way that suggested emphasis, appeared to be generating strong electromagnetic signals. It was a picture of the solar system, and the highlighted planet was Earth. They were telling us they knew we were here, Chen explains, not just that they'd detected our radio transmissions, but that they understood what those transmissions meant. They knew they were looking at a technological civilization, and they wanted us to know that they knew. The implications spread through the scientific community like wildfire. This wasn't just some automated probe mindlessly following ancient programming. This was active communication, tailored specifically for human understanding. Whoever or whatever had created 3I Atlas had studied us enough to construct a message we could decode and comprehend. But why? What did they want? And why now, after billions of years of apparent cosmic silence? Dr. Marcus Webb, a physicist at MIT specializing in interstellar communication, proposed a troubling theory. He pointed out that 3I Atlas had arrived at a very specific moment in human history, just as our technological capabilities had reached the point where we could detect and analyze interstellar objects. We'd only discovered our first such visitor, Oumuamua, in 2017. Our detection networks, our analytical tools, our understanding of what to look for, all of it was brand new. The timing is suspicious, Webb argued in a paper that went viral. If 3I Atlas had arrived a century earlier, we might have missed it entirely or dismissed it as a comet. A century later, we'll probably have much more sophisticated detection systems, but it arrived exactly when we were capable of noticing it and recognizing that something was unusual, but not so advanced that we could do much about it. That suggests intention. The question hung in the air, unanswered but impossible to ignore. Was 3I Atlas waiting for us to notice? The 7 fragments continued their journey through the inner solar system, maintaining their geometric formation with eerie precision. Telescopic observations revealed more puzzling details. The surfaces of the fragments appeared to be changing, developing patterns that might have been surface features or might have been something else entirely. Spectroscopic analysis showed that the composition of each fragment was slowly shifting, as if they were manufacturing new materials or reconfiguring their molecular structures. On June 1, 2024, the fragments performed another coordinated maneuver. Over the course of 6 hours, they folded their heptagonal formation into a 3-dimensional structure, a kind of geometric cage or framework hanging in space. Then, they began to pulse with visible light, bright flashes synchronized with their radio transmissions. Anyone with a decent telescope could now see them blinking like signal beacons against the darkness of space. Amateur astronomers around the world captured the phenomenon. Videos flooded the internet showing the 7 points of light flashing in their complex pattern. Musicians claimed they could hear melodies in the rhythm. Mathematicians found fractal patterns in the intervals between pulses. And everyone wondered what it meant. Dr. Chen's team made another breakthrough on June 7, 2024, just 1 week before 3 Atlas would make its closest approach to Earth. They'd been analyzing the high-resolution images from Hubble, looking for any detail that might provide insight into the object's construction or origin. One of the graduate students, working late into the night with fresh coffee and determination, noticed something in the most recent images that had been missed before. The surfaces of the fragments weren't random. When viewed from certain angles and with specific filtering, the pits and ridges on each fragment's surface formed patterns, and those patterns, when properly translated and arranged, resolved into another image. It was a map of Earth's continents. Not current Earth. The coastlines were wrong, the ice caps different. It looked like Earth as it might have appeared thousands or even millions of years ago, or as it might appear in the future after climate change and geological processes had reshaped the surface. That discovery changed everything, Chen recalls, her expression troubled, because it meant that whoever sent 3I Atlas had information about Earth that they couldn't have obtained from just intercepting our radio transmissions. Our broadcasts only go back about a century. But this map suggested knowledge of our planet's deep history or detailed modeling of its geological future. They knew things about us that we'd never told them. The revelation sent shockwaves through the scientific community and beyond. If 3I Atlas's creators had that level of knowledge about Earth, what else did they know? How long had they been watching? And most disturbing of all, had they been here before? Archaeologists and anthropologists suddenly found themselves consulted by astrophysicists, asked to review ancient texts and artifacts for any evidence of previous contact. SETI researchers began combing through old data with new urgency, looking for signals they might have missed. Historians examined records of unusual astronomical events, searching for patterns that might indicate earlier visits. Nothing conclusive emerged, but the questions persisted, gnawing at the edges of collective human understanding. We had thought ourselves alone in the cosmos, or at least unnoticed. Now it appeared that someone had been paying very close attention for a very long time. On June 12, 2024, 48 hours before its closest approach to Earth, the 7 fragments of 3I Atlas performed their most dramatic transformation yet. The geometric framework they'd constructed began to shimmer with electromagnetic activity. Radar observations showed that the structure was generating powerful magnetic fields, far stronger than any natural process could explain. And then, slowly at first, but with increasing speed, the fragments began to move toward each other. They weren't colliding. The movement was too controlled for that. They were reassembling, fitting together like pieces of an impossibly complex puzzle. The entire process took exactly 47 minutes, and when it was complete, 3I Atlas existed once again as a single object, but it was no longer the irregular rocky body that had been first detected in April. The reassembled form was geometrically perfect, a dodecahedron approximately 900 meters across, its faces smooth and reflective as polished metal. It hung in space like a gigantic diamond, catching and reflecting sunlight in brilliant flashes that made it visible to the naked eye from Earth's surface. Dr. Yamamoto was among the first to observe the transformation through Hubble. His hands were shaking as he adjusted the telescope's instruments, unable to quite believe what he was seeing. "It was beautiful," he says simply. "Terrifying, yes, but beautiful. We were looking at technology beyond anything we could imagine, something that could reconfigure itself at will, that could fold and unfold through dimensions we were only beginning to understand. And it was right there, so close we could almost touch it." The dodecahedron began a new transmission, broadcasting on multiple frequencies simultaneously. This signal was different from all the others. It contained video data, three-dimensional models, and something that appeared to be acoustic information. Scientists scrambled to decode and assemble the transmission, working through the night as 3I Atlas approached its closest point to Earth. What they found, when the data was finally compiled, was a message that defied all expectations. It wasn't a greeting. It wasn't a threat. It wasn't a request or a demand. It was a warning. The transmission showed the solar system, but not as it currently existed. It showed the future, or rather, a possible future. In the simulation, a wave of radiation was sweeping through the galaxy, originating from somewhere beyond the galactic core. The wave was subtle, invisible to most forms of detection, but its effects were catastrophic. Stars flickered and died, planets lost their magnetic fields, complex chemistry broke down into simpler forms, and Earth, in this visualization, went dark. The message indicated that this wave, whatever it was, would reach our region of space in approximately 47 years. The precision of that number, matching the mysterious 47-minute cycle that had characterized 3I Atlas since its discovery, was impossible to ignore. But the message didn't end with the warning. The final portion of the transmission showed the same scenario, but with a difference. In this version, geometric structures like 3I Atlas itself were positioned throughout the solar system, creating a kind of defensive network. When the wave arrived, these structures activated, generating fields that deflected or absorbed the dangerous radiation. Earth survived. The implications were staggering, almost too large to grasp. 3I Atlas wasn't just a visitor or a probe. It was an offer of protection, a technological solution to a threat we hadn't even known existed. But who was making this offer? What would acceptance cost? And was any of it even real? Dr. Webb voiced the question that many were thinking, but few wanted to ask aloud. How do we know this warning is genuine? How do we know this isn't manipulation, a way to get us to accept their technology, their presence in our solar system? We're being asked to trust beings we don't know, understand, or even communicate with effectively. That's a terrifying leap of faith. The debates that followed were intense and often bitter. Scientists were divided. Some argued that the warning should be taken seriously, that the sophistication of 3I Atlas's technology suggested creators who would have no need to deceive humanity. Others insisted that caution was paramount, that accepting alien technology could fundamentally alter human civilization in unpredictable ways. Governments held closed-door sessions, trying to formulate policy in a situation where no precedent existed. Religious leaders interpreted the arrival in theological terms. Philosophers debated the ethics of accepting help from an unknown source. And ordinary people around the world looked up at the night sky, seeing for the first time in human history a visible artificial object that hadn't been created by human hands. On June 14, 2024, at exactly 3:47 p.m. Greenwich Mean Time, 3I Atlas reached its closest approach to Earth, a distance of approximately 15 million kilometers, about 40 times the distance to the Moon. At that moment, every telescope on Earth and in orbit was trained on the dodecahedron, watching and waiting. It began to glow, not with reflected sunlight, but with its own luminescence, a soft blue radiance that made the geometric faces of the structure seem to pulse with inner life. The radio transmissions increased in intensity and complexity, and then, without warning or preamble, 3I Atlas broadcast its final message. It was simple, just a few mathematical expressions and a set of coordinates in space. Dr. Petrov's team decoded it within minutes, and what they found made her stop breathing for a moment. The coordinates pointed to a location in the outer solar system, beyond the orbit of Neptune, in a region of space that human probes had never visited. And the mathematical expressions described a specific gravitational signature, the signature of a massive object that shouldn't exist there, according to our current understanding of the solar system's structure. 3. Atlas was telling us where to look. It was showing us that our understanding of our own cosmic neighborhood was incomplete. There was something out there in the darkness, something large and hidden that we'd somehow missed in all our centuries of observation. That message changed the entire nature of the conversation, Chen explains. Before, we could debate whether 3I Atlas was real or a hoax, whether its warnings were genuine or manipulation. But now it had given us something testable, something we could verify independently. If we pointed our telescopes at those coordinates and found nothing, then we'd know 3I Atlas was lying or mistaken. But if we found something... She doesn't finish the sentence. She doesn't need to. The astronomical community mobilized once again, redirecting instruments to the specified coordinates. The wait was agonizing. It would take hours to collect enough data to determine if anything was there. In the meantime, 3I Atlas continued its journey, passing Earth and heading toward the inner system, toward the Sun itself. Dr. Yamamoto was the first to confirm it. Using infrared observations from the James Webb Space Telescope, which could detect heat signatures invisible to optical telescopes, he found exactly what 3I Atlas had promised. There was an object at those coordinates, massive and dark, radiating just enough heat to be detected if you knew exactly where and how to look. The object was approximately 3,000 kilometers in diameter, larger than Pluto, larger than any known trans-Neptunian object. It was reflecting almost no light, making it effectively invisible to conventional observation. But it was there, real and undeniable, exactly where 3I Atlas said it would be. The discovery sent the scientific community reeling. How had we missed something so large? More importantly, what was it? A rogue planet captured by the sun's gravity, a primordial remnant from the solar system's formation, or something else, something that had been deliberately placed in the outer darkness where we wouldn't notice? And the most unsettling question of all, had 3I Atlas shown us this hidden object as proof of its knowledge and good faith, or as a warning of something more sinister? The dodecahedron continued toward the sun, now moving on a trajectory that would take it dangerously close to the solar surface. Astrophysicists calculated that if it maintained its current path, it would pass within a few million kilometers of the sun's photosphere, close enough to be torn apart by tidal forces and incinerated by the intense radiation. Speculation ran wild. Was 3I Atlas on a suicide mission, planning to plunge into the sun after delivering its message? Was this some kind of test to see if humanity would try to intervene or offer help? Or was the object executing a complex gravitational maneuver that would slingshot it back out of the solar system at even greater speed than it had arrived? Dr. Chen and her colleagues worked frantically to model all possible scenarios. The math was clear. At its current trajectory and velocity, 3I Atlas would be destroyed. There was no way for something that size to survive a close passage by the sun, no matter how advanced its technology might be. Unless, of course, that technology was even more sophisticated than anyone had imagined. On June 19, 2024, as 3I Atlas approached within 10 million kilometers of the sun, it began to change again. The smooth faces of the dodecahedron started to open, unfolding like petals on some cosmic flower. What had appeared to be solid surfaces revealed themselves to be incredibly thin membranes, perhaps only meters thick but covering enormous areas. The structure expanded, growing larger and larger until it resembled a gossamer sphere surrounding a geometric core. It was building a solar sail, but on a scale that made human attempts at such technology look like children's toys. The membrane, whatever it was made of, began reflecting solar radiation with perfect efficiency. And 3I Atlas, instead of falling into the sun, began to accelerate outward, riding a wave of solar pressure that humans could barely measure, but which the alien technology harnessed with breathtaking effectiveness. The object was leaving. It had delivered its message, proven its credibility, and now it was departing the solar system. But it wasn't going back the way it had come. Its new trajectory would take it in a different direction entirely, toward a region of space that contained no particularly notable stars or features. It was heading into the void, toward whatever distant purpose had brought it here in the first place. Dr. Petrov's team detected one final radio transmission as 3I Atlas receded, its solar sail now spanning nearly 1,000,000 kilometers from edge to edge. The message was brief, containing only two elements: a timestamp indicating a date exactly 47 years in the future, and the same coordinates in the outer solar system that had led to the discovery of the hidden massive object. The meaning seemed clear, though it was open to interpretation. Something was going to happen at that location, on that date. Whether 3I Atlas would return, whether that was when the supposed radiation wave would arrive, or whether something else entirely awaited us, none of that was specified. We were simply given a date and a place, and left to prepare however we saw fit. As July 2024 began and 3I Atlas faded from view, becoming once again just another point of light lost among the stars, the world found itself transformed in ways both obvious and subtle. The knowledge that we weren't alone, that intelligent beings existed somewhere in the cosmos and were capable of reaching across the void to touch our world, this changed everything and nothing simultaneously. Governments established new agencies dedicated to studying the phenomenon and preparing for whatever might come in 47 years. Scientists launched ambitious projects to build better detection networks, more powerful telescopes, and deeper space probes. The massive hidden object in the outer solar system became the target of multiple mission proposals, with space agencies competing to be the first to send a craft to investigate it up close. But there was also fear, the kind that settles into the collective unconscious and never quite dissipates. We had been noticed. We had been measured and found, what? Worthy of warning? Interesting enough to communicate with, or simply convenient for some purpose we couldn't yet fathom? Dr. Chen continues her work, analyzing the data collected during those remarkable weeks when 3I Atlas graced our skies. There's enough information to keep researchers busy for decades, each detail potentially holding clues to the nature of the object's creators and their intentions. The hardest thing, she says, is living with uncertainty. We have this warning, this deadline, but no way to verify it independently. We have proof that something incredibly advanced exists out there, but no way to contact them or ask questions. We're like children who've glimpsed something in the shadows. We know it's there, but we don't know if it means us harm or good, if we should run toward it or away from it. She pauses, looking out her window at the afternoon sky, where somewhere among those distant stars, 3I Atlas continues its journey to unknown destinations. In 47 years, we'll have our answer. The question is whether we'll be ready for it, whatever it turns out to be. The cosmos has revealed itself to be stranger and more populated than we ever imagined. The comfortable fiction that we might be alone, that our little blue world might be the only spark of consciousness in an indifferent universe. That fantasy died on the day 3I Atlas arrived. Now we must live with the knowledge that we are observed, that our actions and choices may have audiences and consequences we can barely conceive. And somewhere in the outer darkness of our solar system, that massive hidden object waits, silent, patient, unknowable, whether it's a threat, a promise, or something that defies human categories entirely, only time will tell. The countdown has begun. 47 years. 47. That number again, woven through the entire encounter like a signature or a clue. What does it mean? Why that specific interval? Is it simply the way the creators of 3I Atlas measure time, or does it have deeper significance? These questions and thousands more occupy the minds of researchers who've dedicated themselves to understanding the visitation. They work with a sense of urgency, tempered by the knowledge that answers, if they come at all, will arrive on a timeline not of our choosing. Meanwhile, amateur astronomers continue to scan the skies, hoping perhaps for another visitor, another message, another chance to understand. Professional observatories maintain their vigil, their instruments pointed at the coordinates 3i atlas provided, watching the hidden object for any sign of change or activity. And in laboratories and universities around the world, humans do what humans do best. We prepare, we plan, we debate, and we dream. We build new technologies and propose new theories. We argue about the meaning of what we've seen and what we should do about it. Because in the end, that's what 3i Atlas has given us. Not answers, but questions. Not certainty, but choice. Not doom or salvation, but possibility. The cosmic mystery it represents is still unfolding, its full implications yet to be revealed. We stand at a threshold, looking out into a universe that has just become infinitely larger and more complex than we ever imagined. What we do next, how we prepare for the date that looms in our future, will define not just our generation, but perhaps the entire future trajectory of human civilization. The night sky looks different now. Those stars that once seemed so distant and indifferent now hold the possibility of being home to minds that think, beings that act, civilizations that span the void between worlds. We are no longer alone in our wondering. Someone, somewhere, is looking back at us. And that changes everything. The months following 3 Atlas's departure were characterized by a feverish intensity that gripped the scientific community and cascaded outward into society at large. What had been witnessed wasn't simply an astronomical anomaly that could be filed away in journals and forgotten. It was a rupture in the fabric of human understanding, a tear through which poured implications that touched every aspect of civilization. Dr. Sarah Chen found herself at the center of a maelstrom she hadn't anticipated. Her modest office at the Harvard-Smithsonian Center for Astrophysics became a pilgrimage site for journalists, documentary filmmakers, government officials, and conspiracy theorists. She hired security after the third break-in attempt by someone convinced she was hiding the real data from the public. People wanted answers I couldn't give them, she recalls, the exhaustion from those months still evident in her voice. They wanted me to tell them definitively whether 3i Atlas was a threat or a gift, whether we should trust the warning or dismiss it as manipulation. But science doesn't work that way. We deal in probabilities and evidence, not certainties and faith. The data from 3i Atlas remained maddeningly ambiguous. Every answer spawned a dozen new questions. The object had demonstrated technology that seemed to violate known physics, the ability to reconfigure matter, generate thrust without visible propulsion, manipulate electromagnetic fields on scales that shouldn't be possible. Yet it had also communicated in ways that were almost deliberately simple, as if tailored for a species just beginning to understand the cosmos. Marcus Webb, the MIT physicist who had questioned the timing of 3i Atlas's arrival, assembled a team to conduct a comprehensive analysis of every aspect of the encounter. They called themselves the Atlas Working Group, and their mission was straightforward: determine, to the extent possible with available data, what 3i Atlas actually was and what its arrival meant for humanity. The group included astrophysicists, materials scientists, linguists, mathematicians, computer scientists, and even psychologists. Webb insisted on the interdisciplinary approach despite criticism from some quarters that it was too unfocused. We were dealing with something that defied categorization, Webb explains. You couldn't approach it purely as a physics problem or a communication problem. It was all of those things and more. We needed perspectives from every field that might shed light on what we'd observed. The first major breakthrough came from an unexpected source. Dr. Yuki Tanaka, a materials scientist at Tokyo University, had been studying the spectroscopic data from 3i Atlas's surface, trying to understand the composition of the dodecahedron structure. She noticed something that the astronomers had missed because they weren't trained to look for it. The material that composed 3i Atlas wasn't uniform. At different wavelengths and under different analytical techniques, It appeared to be made of different substances. In visible light, it looked like a metallic alloy. In infrared, it resembled a complex polymer. In ultraviolet, it showed characteristics of crystalline structures. The spectroscopic signatures were contradictory in ways that should have been impossible. It was as if the material itself was quantum in nature, Tanaka explains, using a whiteboard to illustrate her findings. Not just composed of atoms that exhibit quantum behavior, all matter does that at small scales, but macroscopically quantum. The material existed in multiple states simultaneously, only collapsing into one specific configuration when observed at a particular wavelength. The implications were staggering. If 3I Atlas was constructed from matter that could exist in superposition at human scales, it would explain many of the object's seemingly impossible characteristics. The shape-shifting, the ability to divide and reassemble, the unusual spectroscopic signatures, all of it could be manifestations of quantum properties somehow maintained in a large-scale object. But maintaining quantum coherence at those scales should be impossible according to current understanding. Quantum states are fragile things, easily disrupted by interactions with the environment. An object hundreds of meters across, constantly bombarded by radiation and particles, shouldn't be able to maintain quantum superposition for more than microseconds. Yet 3I Atlas had maintained it for months. Either our understanding of quantum mechanics is fundamentally incomplete, Tanaka concluded, or whoever built 3I Atlas has discovered ways to stabilize quantum states that we can't even theorize about yet. Either possibility is profound. The discovery energized the research community. If macroscopic quantum coherence was possible, it opened doors to technologies that had been relegated to science fiction. Quantum computing at room temperature, materials that could change their properties on demand, possibly even manipulation of space-time itself. The practical applications were almost limitless, but it also deepened the mystery. Why would beings with such advanced technology bother communicating with humanity? What could we possibly offer them? And why deliver a warning about a threat decades in the future, rather than simply protecting us directly if that was their intention? Dr. Elena Petrov, working with the radio astronomy data, made her own unsettling discovery. She had been analyzing the 1.42 gigahertz transmissions from 3I Atlas, looking for patterns or information that might have been missed in the initial analysis. What she found was a layer of data hidden within the carrier signal itself, information encoded in the phase relationships between different components of the transmission. It was steganography on a cosmic scale, Petrov explains. The obvious message was just the surface. Underneath, woven into the fabric of the signal itself, was another message entirely. And that message was much more complex. The hidden data took weeks to fully extract and analyze. When finally decoded, it revealed something that fundamentally altered the scientific community's understanding of 3I Atlas's mission. The hidden message contained detailed astronomical data, positions and characteristics of thousands of stars, many of which were unknown to human science because they were too distant or too faint for our telescopes to have cataloged. But these weren't random stars. When mapped, they formed a three-dimensional structure through the galaxy, a network or pathway connecting star systems across vast distances. And that network had a pattern. Every 47 light-years along the pathway, there was a marker, a star system with specific characteristics that didn't match natural formation patterns. They were showing us a map, Petrov states, her voice carrying a mixture of wonder and unease. Not just of stars, but of something built among the stars, an infrastructure spanning the galaxy, with nodes spaced at regular intervals. And our solar system, while not directly on one of the main routes, was close enough to one of these nodes to be within range. The discovery sparked intense debate. Was this network a transportation system, a communication grid, or something else entirely? Were the nodes natural phenomena that 3I Atlas's creators had simply marked and cataloged, or were they artificial constructs? And most pressingly, what did it mean that humanity existed near but not on one of these pathways? Dr. Ramon Vega, who had first documented 3I Atlas's shape-shifting behavior, proposed a controversial interpretation. He suggested that the network might be a kind of early warning system, a galaxy-spanning detection grid designed to identify and track whatever threat 3I Atlas had warned about. The radiation wave, or whatever it actually was, might be something these builders had encountered before and were preparing to face again. Think of it as a cosmic immune system, Vega explained at a packed conference in Geneva. The nodes detect the threat, communicate with each other, and coordinate a response. 3I Atlas might be a mobile unit within that system, sent to worlds near the network to warn them and offer protection. We're not the destination. We're a neighbor who needed to be notified. The theory was elegant and disturbing in equal measure. It suggested that whatever had created 3I Atlas was working on timescales and spatial scales almost incomprehensible to human thinking. A network spanning the galaxy, with nodes thousands of light-years apart, implied a civilization or collective of civilizations that thought in terms of deep time and vast distance. Human history, all of recorded civilization, would be a mere eye blink to such beings. Meanwhile, the massive hidden object in the outer solar system, the target of the coordinates 3I Atlas had provided, became the focus of intense scrutiny and planning. Multiple space agencies proposed missions to investigate it, but the distances involved made quick action impossible. Even the fastest spacecraft humanity could currently build would take years to reach the object's location beyond Neptune's orbit. NASA, working with the European Space Agency and the China National Space Administration, began development of what they called the Sentinel mission. The plan was to send a nuclear-powered probe equipped with the most advanced sensors available to conduct a close flyby of the hidden object, potentially entering orbit if it proved safe to do so. Dr. Jennifer Morrison, the mission director, faced enormous pressure from multiple directions. The public wanted answers immediately. Politicians wanted guarantees of success. Scientists wanted instrumentation that would maximize data collection, and everyone wanted the mission launched as soon as possible. We were designing a mission to investigate something we knew almost nothing about, Morrison explains, gesturing at the blueprints and technical specifications covering her office walls. We didn't know if it was a planet, a spacecraft, a weapon, or something we didn't have categories for. We had to prepare for every contingency, while knowing we probably hadn't imagined the actual situation we'd encounter. The design process revealed just how unprepared humanity was for the realities of deep space exploration. The object was in a region where solar power was useless, too far from the sun to generate meaningful energy from solar panels. Communication delays would be measured in hours. If something went wrong, there would be no possibility of real-time troubleshooting or rescue. The probe would be entirely autonomous, making decisions based on programming created by engineers who had to anticipate scenarios they could barely conceive. As 2024 turned into 2025, the world began to adapt to its new reality. The existence of advanced non-human intelligence was no longer a question of if, but of confirmed fact. The psychological and philosophical implications rippled through every aspect of society. Religious institutions grappled with theological questions that had been theoretical for centuries. If intelligent beings existed elsewhere in the cosmos, how did that fit with various creation narratives and concepts of humanity's special place in the universe? Some faith traditions adapted quickly, arguing that divine creation could certainly encompass multiple worlds and multiple forms of intelligence. Others struggled with the implications, and schisms opened within denominations over how to interpret the new reality. Educational systems revised curricula to incorporate the implications of contact with non-human intelligence. Philosophy departments expanded courses on ethics and first contact protocols. Science programs emphasized the importance of SETI research and exoplanet studies. A new generation of students grew up knowing with certainty that humanity was not alone, that the universe was populated, and that our actions might have audiences beyond Earth. The economic impacts were complex and far-reaching. Space industry stocks soared as governments and private companies poured resources into exploration and defensive technologies. The hidden object's existence sparked a new space race, with multiple nations and private entities competing to be first to reach it. Asteroid mining ventures, previously dismissed as too expensive and speculative, suddenly attracted serious investment as people realized that access to space resources might become critical for survival. But there was also fear, deep and pervasive. The warning about the radiation wave, scheduled to arrive in 47 years, hung over everything like a sword, suspended by a thread. Some people argued for massive investment in defensive technologies and space infrastructure. Others insisted that the warning might be false, a manipulation designed to make humanity dependent on external help or technology. The debates grew heated and sometimes violent. Dr. Chen watched these developments with growing concern. The unity and wonder that had characterized the initial response to 3I Atlas was fracturing into competing factions with incompatible visions of how humanity should respond. I started to understand how first contact could be destabilizing even when it's peaceful, she reflects. It wasn't that 3I Atlas threatened us directly. It was that its mere existence forced us to confront questions we weren't ready to answer. Questions about our place in the cosmos, our level of development, our ability to protect ourselves. We wanted to believe we were mature enough for this moment, but the evidence suggested otherwise. The Atlas Working Group continued its analysis, publishing papers that attempted to piece together a coherent picture from fragmentary data. Dr. Kenji Yamamoto made another significant discovery using archived data from various space telescopes. He had been looking at observations of the region of space that 3I Atlas had traveled through on its approach to the solar system, trying to find any trace of its passage through interstellar space. What he found was absence. Along the path that 3I Atlas must have taken, there were gaps in the cosmic microwave background radiation, tiny voids where the expected signal was slightly diminished. The pattern suggested that something had been absorbing or deflecting that radiation, creating a shadow through space that stretched back for light years. It meant that 3I Atlas had been traveling for a very long time, Yamamoto explains, showing the data visualization that maps the shadow path through three-dimensional space. Based on the length of the trail and its velocity, we estimated that the object had been in transit for at least several thousand years, possibly much longer. It had crossed vast stretches of interstellar space to reach us. The implication was humbling. Whatever intelligence had sent 3I Atlas had committed to a mission that would take millennia to complete. They had launched an object toward our solar system when human civilization was barely beginning, when we had no radio telescopes to detect its approach, no spacecraft to intercept it, no way of knowing it existed. They had sent 3I Atlas not to the humanity that existed when it was launched, but to the humanity they calculated would exist when it arrived. They had predicted our technological development across thousands of years and timed their messenger to arrive at precisely the moment we would be capable of understanding it. The precision was breathtaking and terrifying in equal measure. Dr. Webb's team made progress on decoding the mathematical structures embedded in 3I Atlas's transmissions. Buried within the data were equations that appeared to describe physics beyond the standard model. New fundamental forces, additional dimensions of space-time, quantum relationships that contemporary physics didn't account for. Whether these equations were descriptive of reality or something else entirely remained unclear, but theoretical physicists pored over them with intense focus. Dr. Lisa Raman, a theoretical physicist at Cambridge, believed she had found something revolutionary in the equations. They described what she called temporal engineering, the ability to manipulate the flow of time itself within localized regions of space. If these equations are correct, Raman stated at a symposium in London, then the builders of 3I Atlas have mastered something we've barely theorized about. They can create bubbles of altered time, regions where time flows at different rates than the surrounding space. That would explain how they could coordinate activities across galactic distances. They're not bound by the speed of light for communication because they can manipulate the temporal dimension itself. The idea was radical enough that many physicists dismissed it outright. Time dilation due to velocity and gravity was well understood and confirmed, but deliberately creating and controlling temporal gradients was something else entirely. Yet the equations were mathematically consistent and they made testable predictions. Several research groups began designing experiments to see if the effects described were actually possible. Meanwhile, observatories around the world maintained constant watch on the coordinates 3I Atlas had provided. The hidden object remained quiescent, showing no signs of activity beyond its faint thermal radiation. But telescopic observations revealed more details about its nature. It wasn't spherical, as initial low-resolution data had suggested. Higher resolution imaging showed it to be roughly cylindrical, approximately 3,000 kilometers long and 800 kilometers in diameter. Its surface was extraordinarily dark, reflecting less than 1% of the light that hit it, darker than any natural object in the solar system. And a spectroscopic analysis revealed something puzzling. The surface appeared to be organic, or at least carbon-rich, more like a comet than a metallic structure. Dr. Yamamoto proposed that the object might be ancient, not thousands, but potentially millions or even billions of years old. If it had been placed in the outer solar system in the distant past, it would have accumulated a coating of organic compounds from interstellar dust and meteorite impacts. The true nature of what lay beneath that dark coating remained unknown. It could be a ship, Yamamoto speculated during a private conversation with colleagues. A generational ark sent here eons ago, its crew long dead or in some form of stasis we can't detect. Or it could be a weapon, dormant until some specific triggering condition. Or a computer, a vast thinking machine running calculations on timescales we can't fathom. We simply don't know. The uncertainty was maddening, but it also drove innovation. Engineers and scientists who had previously worked on theoretical problems suddenly found their expertise in demand for practical applications. How do you design sensors to detect technology that might operate on principles you don't understand? How do you communicate with intelligence that might perceive reality in fundamentally different ways? How do you prepare for a threat you can't characterize? In December 2025, the Sentinel mission probe was completed and transported to the launch facility at Cape Canaveral. The spacecraft was a marvel of human engineering, incorporating the latest advances in propulsion, power generation, and autonomous systems. It carried instruments designed to analyze everything from magnetic fields to gravitational anomalies, from chemical composition to quantum states. But even as the final preparations were underway, doubts persisted. Dr. Morrison received a confidential briefing from the intelligence community that gave her pause. Signals intelligence had detected unusual patterns in communications from several nations' military space programs. There were hints that some governments were developing weapon systems designed to target the hidden object, planning to destroy it before the Sentinel probe could even arrive. They saw it as a threat that needed to be eliminated, Morrison explains, her frustration evident. Never mind that we had no evidence it was hostile. Never mind that destroying it might be exactly the wrong thing to do. There were people in positions of power who wanted to shoot first and ask questions never. She spent weeks in classified meetings, arguing that premature military action could be catastrophic. If the object was part of the defensive network 3I Atlas had implied, destroying it might leave Earth vulnerable to whatever threat was approaching. If it was a test of humanity's wisdom and restraint, attacking it would be failing that test. And if it was something else entirely, something beyond current understanding, the consequences of destruction could be unpredictable and potentially disastrous. Eventually, an agreement was reached. The Sentinel probe would launch and conduct its investigation. Military assets would remain on standby, but would not act unless the probe detected an imminent threat. It was an uneasy compromise, satisfying no one completely, but preventing immediate conflict. The launch was scheduled for January 15, 2026. In the days leading up to it, a strange mood settled over the scientific community and the watching world. This was humanity reaching out to touch the mystery that had been revealed to us. For the first time, we were actively investigating evidence of non-human intelligence rather than passively observing it. Dr. Chen traveled to Cape Canaveral for the launch, joined by many of the scientists who had studied 3I Atlas. They gathered in the viewing area as dawn broke over the Atlantic, watching the sleek spacecraft atop its launch vehicle, fueled and ready. I remember thinking about all the missions I'd watched before, Chen recalls. Probes to Mars, to Jupiter, to Pluto. Each one had been exciting, a step into the unknown. But this was different. This wasn't exploring our solar system. This was investigating evidence of someone else's presence in our solar system. The distinction felt profound. The countdown proceeded without incident. At T-0, the engines ignited with a roar that shook the ground kilometers away. Sentinel rose on a pillar of fire, accelerating rapidly as it climbed toward orbit. The assembled scientists and officials watched in silence, each absorbed in their own thoughts about what this mission might reveal. The spacecraft performed its orbital insertion flawlessly. Over the following days, it conducted system checks and calibrations before firing its nuclear electric propulsion system for the long burn that would send it toward the outer solar system. The acceleration was gentle but constant. Sentinel would spend months building up the velocity needed to reach its target in a reasonable time frame. As the probe began its journey, Dr. Petrov's team continued analyzing the radio data from 3I Atlas. They had been working on a puzzle that had bothered them since the initial contact. Why had 3I Atlas used such a simple communication method? An intelligence capable of building something like that dodecahedron should have been able to construct far more sophisticated messages. The answer, when they finally understood it, was both elegant and slightly disturbing. The simplicity was deliberate. 3I Atlas had been designed to communicate at the level of whoever encountered it. The messages it sent were calibrated to be just slightly beyond humanity's current capabilities, complex enough to be interesting and informative, but not so complex that we couldn't decode them with effort. It was teaching us, Petrov explains. Each message built on the previous ones, introducing new concepts and techniques gradually. The hidden data in the carrier signal, the quantum properties of its structure, the advanced physics in its transmissions. These weren't showing off. They were a curriculum, a progression designed to expand our understanding step by step. This realization led to a flurry of renewed analysis. If 3I Atlas had been teaching, what lessons had been missed? Were there layers of information in the data that researchers hadn't yet discovered because they hadn't learned to look for them? Dr. Tanaka, returning to her materials analysis with this new perspective, found something remarkable. The spectroscopic data from 3I Atlas's surface, when analyzed in a specific sequence suggested by the mathematical progressions in the radio transmissions, resolved into something that looked like blueprints, detailed technical schematics for structures and devices, encoded in the way light interacted with the dodecahedron's quantum superposition material. They left us plans, Tanaka states, her voice filled with wonder. Instructions for building technologies far beyond our current capabilities, power generation systems that work by tapping quantum vacuum fluctuations, propulsion methods that manipulate space-time geometry, even what appears to be a defensive system similar to what 3I Atlas showed in its warning message. Everything we'd need to prepare for the threat they warned us about, they left it all encoded in their structure, waiting for us to be smart enough to find it. The discovery triggered a global debate that made previous controversies seem tame by comparison. Should humanity attempt to build these technologies? We didn't fully understand the principles behind them. We couldn't predict all the consequences of deploying them, and there was always the possibility that this was exactly what 3I Atlas's creators wanted: humanity dependent on their technology, integrated into their systems, no longer fully autonomous. The debates raged in scientific journals, government chambers, public forums, and social media. Humanity had been given a gift, or a trap, or a test, or possibly all three simultaneously. How we responded would shape the future of the species in ways that were becoming increasingly difficult to predict. Dr. Webb, who had questioned 3I Atlas's motives from the beginning, found himself in an uncomfortable position. His warnings about caution and skepticism were being used by factions that wanted to ignore the warning entirely, to continue as if nothing had changed. But that wasn't his position at all. "I'm not saying we should dismiss what 3I Atlas told us," Webb clarified in a widely viewed interview. "I'm saying we should verify everything we can, proceed carefully, and maintain our independence and agency. Yes, they've shown us advanced technology. Yes, they've warned us of a threat, but we don't know their full agenda, and we shouldn't blindly trust beings we don't understand. Trust should be earned, even across the stars. His position represented a middle ground that many found reasonable. Take the warning seriously, study the provided technology carefully, but maintain critical thinking and independence. Don't assume benevolence, but don't assume malevolence either. Proceed with eyes open and minds engaged. As 2026 progressed, research teams around the world began carefully investigating the technological blueprints encoded in 3I Atlas's structure. They started with the simplest systems, trying to understand the principles before attempting to build anything. The power generation design was particularly intriguing. It appeared to extract energy from quantum fluctuations in vacuum space, tapping into what physicists called zero-point energy. Dr. Raman's team at Cambridge built a small-scale prototype based on the blueprints. It was barely larger than a shoebox composed of exotic materials that had taken months to fabricate. When they activated it for the first time, the results were simultaneously thrilling and disturbing. The device worked. It generated measurable power, approximately 100 watts, with no apparent energy input. The power output was steady and continuous, showing no signs of depletion. They ran it for 2 weeks straight, and it never varied by more than a fraction of a percent. We had created a machine that violated the first law of thermodynamics, Raman explains, though she's quick to add qualifications. Or so it appeared. In reality, it was drawing energy from quantum vacuum fluctuations, which technically doesn't violate conservation of energy because the vacuum isn't really empty. But from a practical standpoint, we'd built a device that generated unlimited power from nothing we could see or measure directly. The implications were staggering. The success of the Cambridge prototype sparked both celebration and concern. If the technology worked, it could revolutionize human civilization. Limitless clean energy would solve countless problems and enable capabilities previously confined to science fiction. But it also meant that the other technologies in the blueprints likely worked as well, including ones whose purposes and effects were less clear. Governments began classifying some of the research, declaring certain technologies too sensitive or dangerous for public development. This led to protests from scientists who believed that the knowledge should be freely shared and developed by the international community rather than hoarded by military establishments. The tensions came to a head in August 2026, when a whistleblower leaked classified documents showing that several nations had begun secret crash programs to develop the more advanced technologies from the 3I Atlas blueprints, including what appeared to be weapon systems. The revelation sparked international outrage and emergency sessions at the United Nations. Dr. Morrison, watching the political chaos unfold while managing the Sentinel mission, felt a deep frustration. We were tearing ourselves apart over gifts we didn't understand from beings we'd never met, she reflects. Instead of uniting in the face of the unknown, we were falling back on old patterns: competition, secrecy, suspicion. I wondered if that's what 3I Atlas's creators had expected, or if they'd hoped we'd be better than this. Meanwhile, Sentinel continued its steady acceleration toward the outer solar system. The probe had been traveling for 8 months and had long since passed the orbit of Jupiter. Its autonomous systems performed flawlessly, conducting routine maintenance and calibrations while storing solar wind data and other environmental measurements. The probe wouldn't reach the hidden object for another 3 years, but every day brought it closer to answers. Dr. Yamamoto maintained regular communication with the probe, or as regular as the light speed delays allowed. Commands sent from Earth took hours to reach Sentinel, and responses took hours to return. He spent his days planning observation sequences and analyzing the slowly changing data as the probe ventured into regions of the solar system that had never been directly explored. In October 2026, Sentinel passed an important milestone. It detected the hidden object directly for the first time. The probe's sensitive infrared cameras picked up the faint thermal signature at a distance of still more than 2 billion kilometers. It was real, it was there, and Sentinel was heading directly toward it. The detection triggered a wave of renewed interest and anxiety. The object that had been purely theoretical, known only through the coordinates provided by 3I to Atlas, was now confirmed by human instruments approaching it directly. In 3 years, give or take a few months, humanity would have close-up images and detailed data about something that shouldn't exist in our solar system, but undeniably did. Dr. Chen, reviewing the detection data from Sentinel, felt a chill that had nothing to do with the temperature of her office. The object was real. 3I Atlas had been telling the truth, or at least part of it. That meant the rest of its message, the warning about the approaching radiation wave, the timeline of 47 years, all of it was more credible now. The clock was ticking. By Chen's calculation, accounting for the time since 3I Atlas's departure, humanity had approximately 44 years to prepare for whatever was coming. 44 years to understand technologies that remained mysterious, to build defenses against a threat that had never been adequately characterized, to unite a species that seemed determined to remain divided. Sometimes I wonder if that's the real test, Chen muses, not whether we're smart enough to understand the technology or brave enough to face an external threat, but whether we're wise enough to work together to transcend our petty divisions in service of collective survival. Maybe that's what 3I Atlas's creators were really measuring when they came here. As 2026 drew to a close, the world had changed in ways both obvious and subtle. The existence of non-human intelligence was now an accepted fact, incorporated into education, policy, and daily life. The technologies derived from 3I Atlas's blueprints were beginning to appear in laboratories around the world, promising revolutionary advances, but also raising profound questions about dependency and autonomy. And somewhere in the outer darkness of the solar system, Sentinel continued its lonely journey toward a rendezvous with mystery. In 3 years, it would arrive at the hidden object and begin its investigation. What it would find remained unknown, but the anticipation was almost unbearable. Dar Petrov, maintaining her radio vigil, even though 3I Atlas had long since departed beyond detection range, made one final discovery as the year ended. Deep in the archived data, in transmissions that had been recorded but not fully analyzed during the chaos of the initial encounter, she found something that had been missed. It was a brief transmission, only a few seconds long, encoded differently than all the other messages. When decoded, it was simpler and yet more complex than anything else 3I Atlas had sent. It was a single equation, elegant and profound, describing a relationship between consciousness and space-time itself. The equation suggested that sufficiently advanced intelligence could affect the structure of space-time through directed will, that thought itself, organized and focused, could become a force acting on physical reality. It was the bridge between mind and matter, between observer and observed, unified in a mathematical expression that implied consciousness was not an accident of physics, but a fundamental feature of the universe itself. If this is true, Petrov whispered to herself as she stared at the equation, then everything changes. We're not separate from the cosmos looking in. We're part of it, able to shape it, responsible for it in ways we never imagined. She sat in the darkness of her observatory, surrounded by instruments that listened to the whispers of the universe, and contemplated what it meant to be human in a cosmos that was stranger, more populated, and more responsive to consciousness than anyone had dreamed. Somewhere out there, 3I Atlas continued its journey toward unknown destinations, carrying with it the hopes, fears, and questions of a species that had suddenly discovered it was not alone. The object had come, delivered its message, and departed, leaving humanity transformed in its wake. But the story was far from over. In the outer solar system, something ancient and massive waited. In laboratories around Earth, technologies beyond current understanding were being carefully decoded and cautiously tested. And in the future, drawing inexorably closer with each passing day, a threat approached that would test everything humanity had learned. The countdown continued. 44 years and counting. The night sky held secrets still, but now humanity knew enough to be afraid of what those secrets might reveal. And in that fear, perhaps, lay the seed of wisdom that 3 Atlas's creators had hoped to plant. The transition from 2026 to 2027 marked what historians would later call the Great Reorientation, a fundamental shift in how humanity viewed itself and its place in the cosmos. The comfortable isolation that had characterized the entire span of human existence was gone, replaced by an uncomfortable awareness that we were being watched, measured, and perhaps judged by intelligences whose capabilities and motivations remained frustratingly opaque. Dr. Sarah Chen found herself at the center of an effort that consumed her life completely. The Atlas Research Consortium, a massive international collaboration funded by 14 nations and coordinated through the United Nations, had appointed her as scientific director. Her mandate was simple to state, but nearly impossible to execute: prepare humanity for what was coming in 43 years. The consortium occupied an entire building in Geneva, a gleaming structure of glass and steel that housed over 800 researchers from every scientific discipline imaginable. Physicists worked alongside biologists, engineers collaborated with philosophers, computer scientists debated with linguists. The atmosphere was electric with possibility and weighted with responsibility. Every morning I walked into that building, I felt the pressure, Chen recalls. 800 brilliant minds looking to me for direction, and I had no map, no precedent, no assurance that anything we did would make a difference. We were trying to decode the intentions of beings who thought on timescales of millennia and operated technologies that seemed like magic. How do you lead in a situation like that? The consortium's work divided into 3 primary streams, each critical to understanding and responding to the 3I Atlas encounter. The first stream focused on decoding and testing the technologies embedded in the blueprints. The second stream analyzed every aspect of 3I Atlas's communications and behavior, searching for patterns and meanings that might have been missed. The third stream modeled potential scenarios for the warned threat and humanity's possible responses. Dr. Lisa Rahman led the technology stream, overseeing teams that were attempting to replicate and understand the devices described in the spectroscopic blueprints. The zero-point energy generator had been just the beginning. The complete set of blueprints included at least 17 distinct technologies, ranging from the relatively comprehensible to the utterly baffling. Some of them we could build, more or less, Rahman explains, walking through the consortium's fabrication laboratory where prototypes in various stages of completion occupied every available surface. The power generators worked, though we still didn't fully understand the quantum mechanics involved. We'd managed to create small-scale versions of the propulsion system that manipulated space-time curvature. They moved without reaction mass, which was revolutionary. She pauses in front of a large metallic sphere, suspended in a magnetic field, rotating slowly in place. But others completely defeated us. This one, for example. According to the blueprints, it's supposed to create localized temporal distortions. We've built it exactly according to specifications, using materials that took 2 years to synthesize. And it does something. Instruments near it show anomalous readings. Clocks run irregularly in its vicinity. But whether it's actually manipulating time or just creating bizarre electromagnetic effects that confuse our instruments, we honestly can't say. The uncertainty was maddening, but also humbling. Humanity had been given the keys to technologies that pushed against the boundaries of known physics, but understanding how to use those keys, and more importantly, whether they should be used, remained elusive. Kenji Yamamoto led the second research stream, coordinating the analysis of every bit of data collected during 3I Atlas's passage through the inner solar system. His teams worked with petabytes of information, spectroscopic readings, radio transmissions, radar data, visual observations across every wavelength from radio to gamma rays. Somewhere in that vast dataset, Yamamoto believed, were answers to the fundamental questions that haunted everyone. Who sent 3I Atlas? What did they really want, and could they be trusted? Data science at this scale is as much art as science, Yamamoto explains, showing visualizations where patterns emerge from apparent chaos, 3-dimensional structures built from millions of data points. We were looking for the signal in the noise, but we didn't know what the signal would look like, or even if one existed. It required new analytical techniques, new AI systems trained to recognize patterns in multi-dimensional data spaces. His teams made several significant discoveries in early 2027. The first was that 3I Atlas's radio transmissions had contained what appeared to be error correction codes embedded within them. Not just simple checksums, but sophisticated redundancy systems that could reconstruct data even if large portions of the transmission were lost or corrupted. This suggested that the creators expected their messages to travel through noisy environments or be received by civilizations with limited technical capabilities. But more intriguingly, when the error correction protocols were applied to transmissions that had been received cleanly with no apparent errors, they revealed additional layers of data. Information within information, like Russian nesting dolls of meaning. It was a test of our sophistication, Yamamoto states. The surface message could be decoded by any civilization with radio astronomy. The first hidden layer required understanding of advanced error correction theory. Deeper layers demanded even more sophisticated analysis. Each layer you could decode demonstrated your level of technical achievement. His teams had successfully decoded 4 layers. They suspected there were at least 2 more, possibly many more, but the analytical techniques required to reach them remained beyond current capabilities. The deepest layer they'd accessed contained something that took weeks to understand, a detailed astronomical catalog showing the positions of thousands of stars, but not as they currently appeared. The positions were offset, shifted from their present locations. When Yamamoto's team finally realized what they were looking at, the implications were staggering. The catalog showed stellar positions as they would appear approximately 47,000 years in the future, accounting for the proper motion of stars through the galaxy. It was a map for the distant future, or possibly a record from the distant past, depending on perspective. They were operating on time frames that made human civilization look like a brief flicker, Yamamoto explains quietly. Everything we'd built, all of recorded history, all of our wars and achievements and struggles, to them, it was probably just a moment, barely worth noting. That realization was both humbling and terrifying. Dr. Marcus Webb led the third research stream, the one focused on threat modeling and response scenarios. His teams included astrophysicists, military strategists, climate scientists, biologists, and disaster response specialists. Their task was to understand what the warned threat might actually be and what humanity could do to survive it. The problem was that we had almost no concrete information, Webb explains, frustration evident in his voice even years later. 3I Atlas showed us a visualization of a radiation wave, but what did that actually mean? Was it electromagnetic radiation, cosmic rays, some exotic form of energy we hadn't discovered yet? The effects shown in the simulation were catastrophic but vague. Stars dying, planets losing magnetic fields, chemistry breaking down. What physical mechanism could cause all of that? His teams developed hundreds of theoretical models, each attempting to match the limited evidence with known physics. Some proposed that the threat was a gamma-ray burst from a distant supernova, powerful enough to strip away planetary atmospheres and sterilize worlds. Others suggested it might be a density wave moving through the galactic magnetic field, capable of disrupting stellar processes and planetary cores. Still others proposed more exotic possibilities, a false vacuum decay event, a dimensional incursion, or even a deliberately engineered weapon deployed by some unknown cosmic adversary. Each model led to different defensive strategies. Protection against gamma rays required different technologies than protection against magnetic field disruption. And some of the more exotic threat models suggested that physical defenses might be insufficient, that survival would require humanity to fundamentally alter its nature or existence in ways that were difficult to contemplate. The uncertainty was paralyzing for policymakers, Webb states. How do you allocate resources to defend against a threat you can't characterize? Do you build physical shields, develop evacuation plans, focus on hardening infrastructure, or invest in technologies that might allow some portion of humanity to escape the solar system entirely? Every choice foreclosed others, and we had no way to know which approach was correct. Meanwhile, halfway between Jupiter and Saturn, the Sentinel probe continued its steady journey toward the outer solar system and the hidden object that waited there. Dr. Jennifer Morrison, the mission director, maintained constant vigilance over the spacecraft systems, watching for any anomaly that might threaten the mission. At that distance, we were utterly dependent on the probe's autonomous systems, Morrison explains. Communication round-trip time was over 3 hours. If something went wrong, Sentinel would have to diagnose and fix itself long before we even knew there was a problem. Every day that the systems continued functioning normally felt like a small miracle. The probe sent back a steady stream of data about the outer solar system environment, measurements of charged particle densities, magnetic field strengths, dust concentrations. Most of it was scientifically interesting, but not immediately relevant to the primary mission. Then, in March 2027, Sentinel detected something unexpected. The probe's radar system, continuously sweeping the space ahead, picked up multiple small objects in the vicinity of the hidden cylindrical structure. They were tiny, none larger than a few meters across, but there were hundreds of them, possibly thousands, arranged in a complex orbital pattern around the massive central object. Morrison's team spent days analyzing the radar returns, trying to understand what they were seeing. The objects appeared to be artificial. Their radar signatures were too uniform, too geometrically precise to be natural debris. They were satellites of some kind, or perhaps smaller components of a larger system, all choreographed in an intricate gravitational dance around the central cylinder. That's when we realized we weren't just approaching an ancient dead relic, Morrison states. Whatever that thing was, it had an active support infrastructure, hundreds or thousands of smaller objects, possibly still functioning, maintaining positions that shouldn't be stable over geological timeframes. Something was controlling them, managing their orbits, keeping the entire system operational. The discovery was both thrilling and terrifying. It suggested that the hidden object was much more than just a passive marker or monument. It was a functioning facility of some kind, potentially capable of action and response. The question was, would it respond to Sentinel's approach? Morrison's team updated the probe's programming, uploading new instructions that would allow it to react more cautiously if the smaller objects showed any signs of hostile intent, but they also felt the weight of responsibility. Sentinel was humanity's emissary to this mysterious system. How it behaved, how it approached, might determine whether the encounter was peaceful or catastrophic. Back on Earth, the political situation continued to deteriorate. The initial unity and cooperation that had characterized the immediate response to 3I Atlas was fracturing under the pressure of competing national interests and ideological differences. Several nations had withdrawn from the Atlas Research Consortium, choosing to pursue independent research programs that operated in secret. Intelligence agencies reported that at least 3 countries had successfully replicated the zero-point energy generators and were working on weaponized versions. The propulsion technology that manipulated spacetime had obvious military applications. Spacecraft that could maneuver without reaction, mass would revolutionize space warfare. And there were darker rumors of experiments with the temporal distortion devices, attempts to create weapons that could age targets rapidly or trap them in time loops. The United Nations Security Council convened emergency sessions to discuss arms control for the new technologies, but the negotiations quickly deadlocked. How do you verify compliance with treaties when the technologies involved operate on principles that most monitoring systems can't detect? How do you enforce agreements when individual nations believe their survival might depend on technological advantage? Dr. Chen watched the political maneuvering with growing despair. The consortium's mission was to prepare humanity for a collective threat, but instead, nations were preparing for conflicts with each other, squandering resources on competition that should have been devoted to cooperation. I understood the logic, she reflects. Each government believed it had a responsibility to protect its own citizens first, and in the absence of certainty about the threat, the known dangers, other nations, other ideologies, other power centers, seemed more real and immediate than some hypothetical radiation wave that wouldn't arrive for decades. But it was still fundamentally short-sighted and potentially suicidal. In June 2027, the consortium published its first major report, a comprehensive assessment of humanity's current understanding of the 3II Atlas encounter and recommendations for future action. The report ran to over 3,000 pages and included contributions from hundreds of researchers across dozens of disciplines. Its conclusions were careful, hedged with appropriate scientific uncertainty, but the core message was unambiguous. The threat described by 3I Atlas was likely real and potentially existential. The technologies provided in the blueprints appeared genuine and could potentially offer protection, but much remained unknown about their operation and potential side effects. International cooperation was essential for any meaningful defensive preparation. And time was limited. 43 years seemed like a long time, but developing, testing, and deploying planetary-scale defensive systems would require decades of intensive effort. The report made specific recommendations: establish an international authority to coordinate defensive preparations, ban weaponization of the provided technologies, accelerate research into the nature of the predicted threat, and prepare contingency plans ranging from planetary evacuation to deep underground shelters for preserving human civilization in the worst-case scenario. The response was predictably mixed. Scientific communities generally embraced the report's findings and recommendations. Several smaller nations without independent space programs or advanced research capabilities strongly supported the call for international cooperation. But the major powers were more circumspect, unwilling to cede sovereignty to an international authority or abandon their independent research programs. Dr. Elena Petrov, working within the consortium's Communications Analysis Division, made a discovery in August 2027 that complicated the situation further. She had been analyzing the quantum properties of 3I Atlas's structure, specifically the way its material existed in superposition states. When examined with new analytical techniques developed by Dr. Tanaka's materials science team, the quantum states revealed patterns that couldn't be natural. It was information storage on a quantum level, Petrov explains, her excitement evident even in recollection. The material itself was a data storage medium, with information encoded in the quantum states of trillions of atoms. The storage density was phenomenal, several orders of magnitude beyond anything we could achieve with our best technology. And it was persistent, stable, not requiring any active maintenance or power. The discovery meant that 3I Atlas had carried far more information than could be decoded from its transmissions alone. The object itself was a library, its structure containing vast amounts of data waiting to be read. But accessing that data would require developing new technologies for quantum state measurement at scales never before attempted. The consortium immediately prioritized this research, assembling teams to develop the necessary quantum sensing equipment. If they could read the data encoded in the samples of 3I Atlas's material, captured by spectroscopic analysis during the object's passage, they might gain access to vastly more information than they currently possessed. But the research was technically challenging and slow. Reading quantum states without collapsing them required exquisite precision. The equipment needed to be isolated from environmental interference to a degree that pushed the limits of engineering. Progress was measured in incremental successes, each one revealing tiny fragments of data that took months to assemble into comprehensible information. Meanwhile, Dr. Yamamoto's team made another significant discovery. They had been analyzing the 47-minute cycle that had characterized so much of 3I Atlas's behavior: the shape changes, the radio, the transmission intervals, the coordination of the 7 fragments. Mathematical analysis suggested that 47 minutes wasn't arbitrary. It was precisely 1/millionth of the orbital period of the hidden object in the outer solar system. The object completed one orbit around the Sun every 89,440 years. 1/millionth of that period was 47.17 minutes, matching the cycle time to within measurement uncertainty. It was a connection we hadn't seen before, Yamamoto explains. 3I Atlas wasn't just pointing us to that object, it was synchronized with it, operating on the same temporal framework. They were parts of the same system, components of a larger whole that spanned the solar system, and that suggested something profound. If 3I Atlas and the hidden object were parts of the same system, then the object wasn't just a dormant relic. It was likely as active and functional as 3I Atlas itself, just operating on a timescale that made its activities nearly imperceptible from a human perspective. Changes that took decades or centuries would be, from the object's frame of reference, rapid and dynamic processes. The implication was unsettling. Humanity was approaching and planning to investigate something that might be operating on timescales so slow that our entire civilization could rise and fall between one of its thoughts and the next. How do you communicate with or understand something like that? In October 2027, Sentinel crossed the orbit of Uranus, reaching a region of the solar system that only two spacecraft, the Voyagers, had previously visited. The probe was now more than 2.8 billion kilometers from Earth, and communication delays exceeded 5 hours one way. The spacecraft was functionally on its own, following pre-programmed instructions and reacting to its environment with the artificial intelligence systems that Morrison's team had carefully designed. The probe's instruments continued to refine data about the hidden object and its surrounding satellites. High-resolution radar imaging revealed that the central cylinder had a complex surface structure, patterns of ridges and depressions that might be natural geology or might be deliberate construction. Some of the satellite objects appeared to be moving, adjusting their orbits in ways that suggested active control. Morrison reviewed each data packet with teams of specialists, everyone searching for clues about what Sentinel would encounter when it finally arrived. The tension was constant and growing. In less than 2 years, the probe would begin its close approach to the object. Whatever happened then would either vindicate the mission or potentially end it in a confrontation that humanity was powerless to prevent or influence. Rahman's technology teams achieved another breakthrough in November 2027. They successfully activated one of the more mysterious devices from the 3I Atlas blueprints, a structure that appeared to generate what they called a field effect around itself. Objects placed within the field exhibited strange properties. They became resistant to radiation, unaffected by strong magnetic fields, and seemingly protected from extreme temperatures. It was a defensive shield, basically, Rahman explains, but unlike anything in science fiction, it didn't deflect or absorb incoming energy. It seemed to alter the properties of matter itself within the field, making it immune to certain forms of interaction. We tested it with everything we had: radiation, lasers, particle beams, electromagnetic pulses. Nothing penetrated the field when it was active. The success was exciting but raised immediate concerns. If this technology could protect against the predicted radiation wave, it should be deployed as widely as possible. But the devices were difficult and expensive to manufacture, requiring materials that existed in limited quantities and production techniques that only a handful of facilities worldwide could manage. Scaling up to produce enough units to protect major population centers would take years, possibly decades. And there was another problem. The fields had a limited volume. A single device could protect perhaps a few hundred people in close proximity. Protecting entire cities would require thousands of devices, and protecting the planet's ecosystems, all the plants, animals, and microorganisms that complex life depended on, was effectively impossible with current technology. The harsh calculus of survival began to dominate planning discussions. If resources were limited and the threat was real, who should be protected? Major population centers, critical infrastructure, genetic repositories, and seed banks to preserve biodiversity? Every choice was a triage decision, an acknowledgement that not everyone and everything could be saved. Dr. Chen found these discussions almost unbearable. She had become a scientist to understand the universe, to expand human knowledge and capability. Now, she was being asked to participate in decisions about who would live and who would die in a hypothetical catastrophe that might or might not occur 4 decades hence. The ethical weight was crushing, she admits. We were making lists, prioritizing populations and resources based on cold utilitarian calculations. And all of it was premised on information from an alien intelligence we didn't understand, concerning a threat we couldn't verify or characterize. What if we were wrong? What if the entire warning was a misunderstanding or manipulation? Then all these preparations, all these terrible choices, would be for nothing. But the alternative, ignoring the warning, dismissing the threat as unlikely or unverifiable, seemed equally irresponsible. The precautionary principle suggested that even low-probability existential risks deserved serious attention and resource allocation. If there was even a 10% chance that the warning was accurate, doing nothing would be unconscionable. In December 2027, Dr. Petrov's team successfully decoded a significant portion of the quantum-stored data in 3I Atlas's material samples. What they found was both illuminating and disturbing. The data contained detailed astronomical observations spanning hundreds of thousands of years, positions of stars, gravitational wave events, supernova observations, all recorded with precision that far exceeded human capabilities. But more significantly, it contained records of civilizations, dozens of them scattered across the galaxy, each at different levels of technological development. Some of the records were ancient, showing civilizations that had flourished and vanished millennia ago. Others appeared more recent, potentially showing civilizations that existed now in the present era, separated from Earth by vast distances, but sharing the same moment in cosmic time. It was proof that we weren't alone and never had been, Petrov states, her voice soft with wonder. The galaxy had been populated with intelligence for millions of years, possibly billions. Civilizations rose, developed technology, expanded into space, and sometimes vanished. And someone, whoever built 3I Atlas, had been watching and recording it all. The records included one entry that matched Earth's position and characteristics, but the data was incomplete. It showed observations from approximately 75,000 years ago, during Earth's last ice age. And then, nothing. No further entries, as if whoever was maintaining the records had stopped updating Earth's file or had decided that continued observation wasn't warranted. Yamamoto and his team debated the meaning of this gap. Had Earth been dismissed as uninteresting, a world that would never develop significant technology? Or had the monitoring simply become less intensive, with updates occurring only at widely spaced intervals? The next scheduled observation might not be for another 25,000 years, meaning 3I Atlas's arrival was an unscheduled visit, prompted by the approaching threat rather than routine surveillance. As 2I-28 began, humanity found itself in a strange liminal state. The initial shock and wonder of first contact had faded, replaced by a kind of anxious routine. People went to work, raised children, pursued dreams and ambitions, all while living with the knowledge that in 42 years, everything might change or end. It was like being diagnosed with a terminal illness as a species, knowing the approximate timeline but unable to do much except prepare and hope. The Atlas Research Consortium continued its work, but the pace was grinding and frustrating. Every answer led to more questions. Every technological success revealed how much remained unknown. The sense of running out of time was constant, even though more than 4 decades remained. Dr. Morrison watched Sentinel's telemetry with increasing intensity as the probe approached the outer edge of the Hidden Objects satellite network. The spacecraft would enter the outer boundary of that orbital zone in March 2028, nearly 9 months earlier than originally estimated. The objects had been closer than initial radar had suggested, or they had moved inward, adjusting their orbits to encounter Sentinel sooner. That suggested intelligence and purpose, Morrison explains. Random orbital mechanics don't produce coincidences like that. Something was managing those satellites, and it had decided to make contact with our probe earlier than we'd anticipated. Whether that was good news or bad, we had no way to know. Morrison's team prepared for first contact between Sentinel and the satellite network, programming the probe to maintain a cautious approach, ready to evade if any objects showed hostile intent. They also prepared a message, a carefully crafted communication explaining who humanity was and why we had sent a probe to investigate. It was uploaded to Sentinel systems, ready to be transmitted if communication was established. Dr. Chen, reviewing the message before it was transmitted, felt the weight of history. This wasn't just a message from the consortium or from the space agencies. It was humanity's introduction to whatever intelligence maintained the hidden object system. How they responded would shape everything that followed. I remember thinking about the Pioneer plaques and the Voyager golden records, Chen recalls. Those had been messages to hypothetical aliens, created more for human benefit than with any real expectation of contact. But this was different. We knew something was out there. We knew it was watching. And we were about to announce ourselves directly, not to the distant cosmos, but to something in our own solar system. The difference between theory and reality was suddenly very real. The message was transmitted on March 15, 2028. It would take 5 hours to reach Sentinel, and then the probe would broadcast it continuously as it approached the satellite network. If there was a response, it would take at least 10 hours to reach Earth, 5 hours for the signal to travel from the outer solar system to the satellites, and 5 hours for any reply to return. The waiting was excruciating. Morrison and her team maintained a constant watch on the communication channels, looking for any signal that might indicate a response. Hours passed, shifts changed, coffee was consumed in quantities that would make cardiologists weep, and still, nothing. Then, at 3:47 a.m. Greenwich Mean Time on March 16, 2028, exactly 47 hours after the message transmission began, the response arrived. It wasn't what anyone expected. Instead of a radio signal or an electromagnetic transmission, Sentinel's instruments detected a gravitational wave pulse, a ripple in space-time itself, emanating from the location of the hidden cylindrical object. The pulse was brief, lasting only a fraction of a second, but its power was enormous. To generate a detectable gravitational wave from 2.9 billion kilometers away required energy expenditures that staggered the eye's imagination. It was like someone had reached across the solar system and tapped on our shoulder, Morrison describes, not with light or radio waves, but by literally distorting space-time. The message was clear. We see you, we acknowledge your presence, and we have capabilities you barely understand. The gravitational wave contained no information in the conventional sense, no encoded data, no message. It was pure demonstration, a flex of technological muscle that established the hierarchy of the situation. Humanity had sent a probe to investigate. The hidden object had responded by casually manipulating the fundamental structure of reality. The response sent shock waves through the scientific community and beyond. Gravitational wave generation at that scale and with that precision required technologies that made everything else seem primitive by comparison. Humanity had only recently developed the ability to detect gravitational waves using laser interferometers kilometers in length. Creating them deliberately as communication signals was centuries beyond current capabilities at minimum. Dr. Raman's teams immediately began analyzing what would be required to generate such a pulse. The calculations were sobering. It would take the equivalent of merging two black holes, or spinning a massive object at relativistic speeds, or manipulating exotic matter in ways that theoretical physics suggested might be possible. But no one had the faintest idea how to actually achieve. It was a reality check, Raman explains. We'd been feeling pretty clever about decoding some of 3I Atlas's blueprints and building prototype devices. Then this happened, and we realized how far we still were from truly understanding what we were dealing with. We were children playing with toys, and we'd just been reminded that adults were in the room. Sentinel continued its approach, now less than 600 million kilometers from the hidden object. The probe's high-resolution cameras began to capture visual images of the central cylinder, though they were still grainy and low detail at that distance. What they showed was troubling. The surface appeared to be changing, developing structures that hadn't been visible before. Either the object was reconfiguring itself, or the approach angle was revealing features that had been hidden. Dr. Yamamoto analyzed the new images with growing concern. The patterns forming on the cylinder's surface weren't random. They were geometric, regular, and they resembled something he'd seen before. The navigation charts encoded in 3I Atlas's transmissions, the network of nodes spanning the galaxy. The object was displaying a map, Yamamoto explains, showing us its place in a larger structure, its connection to something that spanned light years. It was identification and warning simultaneously. You're not dealing with an isolated artifact, but with a node in a galactic network. Whatever you do here will have consequences elsewhere. The realization shifted the entire context of the mission. Sentinel wasn't approaching a relic or an abandoned facility. It was making contact with an active component of infrastructure that potentially connected to beings and systems across the galaxy. The probe's actions, and by extension humanity's actions, would be observed and possibly judged by intelligences far beyond our ability to comprehend. Morrison and her team adjusted Sentinel's approach parameters, making the trajectory even more cautious. The probe would pass through the satellite network at a safe distance, observing and collecting data but making no aggressive moves. It would be the most peaceful, non-threatening approach they could design, all while acknowledging that threatening might mean something completely different to an intelligence that could manipulate space-time for casual communication. As March turned to April 2028, the world watched and waited. News organizations provided constant coverage of Sentinel's approach. Social media exploded with speculation and theories. Religious leaders offered prayers and interpretations. And in government chambers and military command centers, people planned for scenarios ranging from breakthrough to catastrophe. Dr. Chen stood in the consortium headquarters, looking up at the massive screen displaying Sentinel's trajectory and the arrangement of satellites it was approaching. In less than 48 hours, the probe would enter the network. Whatever happened then would either open new chapters in human understanding or close them forever. I thought about all the effort, all the brilliant minds, all the resources we'd poured into understanding 3I Atlas and preparing for what it warned us about, Chen reflects. And I realized that despite everything we'd learned, we were still fundamentally in the dark. We didn't know who had built these objects, what they wanted, or whether their intervention in human affairs was benevolent, malevolent, or something beyond those categories entirely. She paused, watching the numbers count down on the screen showing time until contact. All we could do was wait and see, and the hope that whoever was watching would judge us worthy of the help they had offered, or at least not be disappointed enough to withdraw it. The countdown continued. 41 years, 11 months, and 2 days until the predicted arrival of the radiation wave, and less than 2 days until Sentinel would enter the satellite network and make contact with whatever maintained it. Humanity held its breath and waited for the cosmos to respond. The hours before Sentinel's entry into the satellite network stretched with an almost physical tension. In the consortium headquarters, Dr. Sarah Chen had ordered round-the-clock staffing, with specialists from every division maintaining vigil over the incoming data streams. The main operations center, a cathedral-like space dominated by enormous display screens, hummed with subdued activity as hundreds of researchers monitored their respective systems. Dr. Jennifer Morrison had flown to Geneva specifically for this moment, leaving the JPL Control Center in California to her deputy. She sat in the front row of the operations center, hands gripping the armrests of her chair with enough force to leave impressions in the leather. Around her, the assembled scientists spoke in whispers, as if loud voices might somehow travel across 3 billion kilometers and disturb the delicate situation unfolding in the outer solar system. The main screen showed a visualization of Sentinel's trajectory, a green line threading through a cloud of red dots representing the satellite objects. The probe was moving at approximately 23 kilometers per second relative to the hidden cylinder, fast enough to cross the satellite network in less than 8 hours, but slow enough by cosmic standards to allow detailed observations. 3 minutes to network boundary, announced a technician, his voice cutting through the murmur of conversation. Morrison felt her mouth go dry. Despite all the planning, all the simulations, all the careful programming, they were about to step into completely unknown territory. The gravitational wave pulse from the cylinder had been their only communication from whatever intelligence controlled the system. It could have been an acknowledgement, a warning, or simply an automated response to an intrusion into monitored space. 2 minutes. Dr. Kenji Yamamoto stood at a side station, monitoring the optical telescopes that were tracking Sentinel's approach. Even at this distance, the most powerful instruments on Earth and in orbit could barely resolve the probe as a single pixel against the darkness. But every photon of reflected light, every bit of telemetry, was precious data. 1 minute. The operations center fell completely silent. Chen glanced around at the assembled scientists, physicists, engineers, linguists, all of them among the brightest minds humanity had produced, and every single one of them was holding their breath, waiting to see what would happen when human technology crossed an invisible line drawn by beings whose capabilities they could barely imagine. Network boundary in 10 seconds, 9, 8, 7. Sentinel crossed the threshold at 1947 GMT on April 18, 2028. For exactly 3 seconds, nothing happened. Then, every screen in the operations center erupted with data. The satellite objects had activated, hundreds of them, possibly thousands, all simultaneously coming alive with electromagnetic activity. Radio emissions across multiple frequencies, laser pulses in visible light and infrared, radar sweeps crisscrossing the space around Sentinel. The probe was being examined by a distributed sensor network of extraordinary sophistication, scanned and analyzed by technologies that operated in concert with flawless precision. Reading massive power spikes from multiple objects, called out Dr. Elena Petrov from her station. They're coordinating, sharing data in real time across the entire network. The bandwidth is incredible, orders of magnitude beyond anything we've achieved. Morrison watched the telemetry from Sentinel flow across her screens. The probe's systems were all functioning normally, showing no signs of interference or attack. The satellites were observing, measuring, cataloging, but not threatening, at least not yet. Sentinel is responding with the prepared greeting sequence, Morrison announced. The probe had been programmed to broadcast a carefully crafted message if the satellites showed active interest. That message was now streaming out into the network. Mathematical constants, representations of atomic structure, information about Earth and its inhabitants, all encoded in formats designed to be decipherable by any technological intelligence. The response came within minutes, far too quickly for light-speed communication from the central cylinder. The satellites themselves were answering, their collective intelligence sufficient to formulate and transmit a reply without consulting whatever higher authority might exist at the network center. The message that came back was complex and multi-layered, encoded in formats that built upon the communication protocols 3i Atlas had established. Dr. Yamamoto's team worked frantically to decode it, their specialized AI systems parsing through the data structures and extracting meaning. What emerged was simultaneously reassuring and deeply unsettling. The network acknowledged Sentinel's presence and identified it as an exploratory probe from a technologically developing civilization. It confirmed that the hidden cylinder was indeed part of the same system as 3i Atlas, a node in the galactic network that the earlier visitor had mapped, and it conveyed something that could only be interpreted as permission. Sentinel could proceed with its investigation, observe and collect data under specific constraints. Those constraints were clear. The probe could not approach within 50,000 kilometers of the central cylinder. It could not attempt to physically contact any of the satellite objects. It could not transmit any signals that might be interpreted as weapons or attack systems. Violation of these constraints would result in immediate neutralization of the probe. "They're allowing us to look but not touch," Morrison summarized, reviewing the decoded message with a mixture of relief and frustration. "We can observe from a distance, but they're making it very clear that there are boundaries we must not cross." Chen nodded slowly. "It's more than we had any right to expect. They could have destroyed Sentinel the moment it entered the network. Instead, they're giving us an opportunity to learn. The question is, what are they willing to let us see?" Over the following days, as Sentinel moved through the satellite network on its carefully controlled trajectory, that question began to be answered in ways no one had anticipated. The probe's instruments captured unprecedented data about the system, revealing layers of complexity that had been invisible from Earth-based observations. The satellite objects, numbering at least 3,700 by Sentinel's count, were arranged in a three-dimensional matrix that formed a kind of cage or shell around the central cylinder. Each satellite was roughly spherical, between 2 and 5 meters in diameter, composed of materials that shifted their spectroscopic signatures in response to the probe's scanning, the same quantum superposition matter that 3i Atlas had been constructed from. But more remarkably, the satellites were connected, not physically, but through fields that Sentinel's instruments could barely detect. Dr. Lisa Raman, analyzing the data from Geneva, proposed that the satellites were linked by manipulation of space-time itself, creating a network of gravitational and temporal connections that allowed instantaneous communication across the entire system. They've built a quantum-entangled mesh on a macro scale, Raman explained to the assembled researchers. Each satellite is quantum mechanically linked to all the others, allowing the network to function as a single distributed intelligence rather than thousands of separate objects. Information propagates through the network faster than light because it's not traveling through normal space. It's using quantum correlations that transcend spatial separation. If true, the implications were staggering. The network wasn't just a collection of sensors and transmitters. It was a single vast computational system with processing power that might exceed all of humanity's computers, combined by orders of magnitude. And that system was now observing Sentinel, analyzing the probe's every action and communication, forming judgments about the civilization that had sent it. Dr. Marcus Webb, monitoring the mission from his position at MIT, found this development particularly troubling. He convened an emergency video conference with Chen, Morrison, and other senior researchers to express his concerns. "We need to be very careful about what we're showing them," Webb argued, his face tense on the video screen. "This isn't just a scientific mission anymore. We're being evaluated, possibly tested. Every decision we make, every question we ask, every scan we perform, it's all data about humanity, about how we think, what we value, what we're capable of. We're revealing ourselves to an intelligence that could be millions of years more advanced than us." Chen understood his concern, but she also saw the opportunity. "What would you have us do, Marcus? Retreat? Stop gathering data? We're here, we're engaged, and backing away now would tell them just as much about us as proceeding carefully forward. Maybe more." "I'm not suggesting retreat," Webb clarified. "I'm suggesting deliberation. We should be thoughtful about which questions we prioritize, which systems we examine most closely, because those choices will reveal what matters to us, what we consider important, and that information could be used to manipulate us or predict our behavior." The debate continued for hours, but ultimately, the mission parameters remained largely unchanged. Sentinel would complete its observation sequence, gathering as much data as possible while respecting the constraints the network had established. Humanity would learn what it could and accept that it was also being learned about in return. As April turned to May 2028, Sentinel began its close approach to the 50,000-kilometer boundary around the central cylinder. At that distance, the probe's high-resolution cameras and spectroscopic instruments could finally capture detailed data about the massive structure that had waited in the outer solar system for unknown eons. What they revealed defied easy categorization or description. The cylinder was approximately 3,000 kilometers long and 800 kilometers in diameter, as earlier estimates had suggested. But its surface was not uniform. It was covered in patterns of extraordinary complexity, geometric designs that seemed to shift and reconfigure as Sentinel observed from different angles. Some portions appeared metallic, reflecting the faint sunlight in sharp glints. Other sections seemed to absorb all incoming radiation, darker than the space around them. And the cylinder was rotating, slowly but measurably, completing one full rotation every 47 hours. The same number again, woven through every aspect of this mysterious system like a signature or a fundamental constant. Dr. Yamamoto, analyzing the surface patterns with pattern recognition AI systems, made a discovery that sent ripples of excitement through the research community. The geometric designs on the cylinder's surface were not random or decorative. They were data, information encoded in physical structure, similar to how 3I Atlas had stored information in quantum states, but on a vastly larger scale. "The entire surface is a storage medium," Yamamoto explained in a hastily organized briefing. "Every ridge, every depression, every change in reflectivity, it's all encoding information. If we could read it all, we'd be looking at the equivalent of exabytes or zettabytes of data. More information than all of human civilization has generated in its entire history." The consortium immediately prioritized developing techniques to decode this information. It would take years, possibly decades, to fully extract and translate all the data encoded on the cylinder's surface. But even partial readings might provide unprecedented insights into whoever had built this structure and what they intended it for. Sentinel continued its observations, instruments working at maximum capacity to capture every possible bit of data before the probe's trajectory would carry it past the network and out toward the farther reaches of the outer solar system. The mission was scheduled to end with a final, high-gain transmission of all collected data, followed by the probe entering a hibernation mode as it continued into interstellar space, following in the footsteps of the Voyagers, but carrying with it knowledge of an encounter that the earlier spacecraft could never have imagined. Then, on May 11, 2028, something unexpected happened. The central cylinder began to change. Sentinel's instruments detected massive energy buildups within the structure. Electromagnetic activity increased by orders of magnitude. Portions of the surface began to open, revealing internal geometries that glowed with their own light. And most dramatically, the rotation rate began to increase, slowly at first, but accelerating measurably with each hour that passed. Morrison's team watched in a mixture of fascination and alarm. The cylinder was activating, responding to Sentinel's presence, or perhaps to some internal schedule that had nothing to do with the probe. Whatever was happening, it was unprecedented in all the time humanity had been observing the object. "The rotation is accelerating geometrically," called out a physicist monitoring the orbital dynamics. "Current period is down to 42 hours and dropping. If this continues, it'll reach significant fractions of the speed of light at the surface. The structural stresses would tear apart anything made of conventional matter." But the cylinder showed no signs of structural failure. Instead, as it spun faster, it began to generate detectable gravitational waves, not the single massive pulse that had greeted Sentinel's message, but a continuous emission pulsing with the rhythm of the rotation. The cylinder was becoming a gravitational lighthouse, broadcasting its presence across the solar system and beyond. Dr. Rahman, watching the energy readings spike higher and higher, suddenly understood what she was seeing. "It's a gyroscope," she breathed, "a relativistic gyroscope. The rotation is stabilizing space-time around it, creating a kind of anchor point. But for what?" The answer came from Dr. Petrov, who had been monitoring the broader stellar environment. "I'm detecting changes in the background gravitational field across the outer solar system, subtle but measurable. The cylinder isn't just spinning, it's doing something to the structure of space around it, creating some kind of field effect that's propagating outward." Chen felt a chill run down her spine. The cylinder was transforming, activating systems that had been dormant for however long it had existed in the outer darkness. And that activation was occurring now, at this specific moment, when humanity had reached out to investigate. Coincidence seemed increasingly unlikely. "Could our probe have triggered this?" Morrison asked, voicing the question everyone was thinking. "Could Sentinel's presence have activated some kind of automated response?" Yamamoto shook his head. "The energy requirements for what we're seeing are enormous. Nothing our probe did could have provided that much power. Whatever triggered this activation, it was either scheduled to happen now regardless of our presence, or—" he paused, reluctant to finish the thought. "Or it's responding to something else," Chen completed. "Something we haven't detected yet." The implications hung heavy in the air. If the cylinder was responding to an external stimulus rather than to Sentinel, what could that stimulus be? Had 3I Atlas sent some kind of signal when it departed the inner solar system, a message that had taken 2 years to reach this distant outpost? Or was something else happening, something related to the threat that 3I Atlas had warned about? Over the following week, the cylinder's transformation continued. Its rotation rate stabilized at 1 revolution every 8.3 hours, and the gravitational field it generated reached a steady state. Sentinel's instruments detected that the field extended outward in a torus shape, a donut of altered spacetime centered on the cylinder's equator and reaching out millions of kilometers into the surrounding space. And within that field, space behaved differently. Light bent at angles that didn't match natural gravitational lensing. Time flowed at different rates, not dramatically, but measurably. And most remarkably, the field appeared to be selectively permeable, allowing some forms of radiation to pass through while blocking others. "It's a filter," Rahman realized, "a selective barrier that can block specific types of radiation while allowing others through. This is what 3I Atlas showed us in the warning. the defensive structures that could protect against the radiation wave. We're seeing one of them activating, preparing for what's coming. The discovery was simultaneously reassuring and terrifying. It confirmed that the warning was real, that actual defensive preparations were underway. But it also meant that whoever controlled these systems believed the threat was real enough to warrant activating defenses decades in advance. They weren't taking chances. Sentinel completed its primary observation mission on May 19, 2028, having collected more data about the hidden cylinder than even the most optimistic mission planners had hoped for. The probe began its programmed departure sequence, firing its thrusters to adjust its trajectory outward, away from the cylinder and the satellite network, toward a path that would eventually take it beyond the solar system entirely. As the probe crossed back out through the satellite network, the objects that had been so active during its approach remained quiescent, merely observing as Sentinel departed. No farewell messages were sent, no final communications. The network had learned what it wanted to learn and was now allowing the human probe to leave, its mission complete. Morrison watched the telemetry with mixed emotions. Success, certainly. Sentinel had survived its encounter and transmitted unprecedented data back to Earth, but also a sense of inadequacy. They had glimpsed something extraordinary, touched the edge of technologies and intelligences far beyond human comprehension, and then been politely but firmly shown the door. We were tolerated, she reflected later, not welcomed. They let us observe because it served some purpose of theirs, not because they wanted contact or connection with humanity. We were like children, being allowed to watch the adults work, learning what we could from observation, but not invited to participate. Back on Earth, the consortium began the massive task of analyzing all the data Sentinel had collected. It would take years to fully process and understand everything the probe had observed. But even the preliminary analysis revealed insights that transformed humanity's understanding of the cosmos and our place in it. The cylinder was ancient, dating back at least several 100 million years based on accumulated surface alterations and orbital dynamics. It had been placed in the outer solar system long before humanity existed, possibly before complex life had evolved on Earth at all. Whatever intelligence had built it was thinking in deep time, planning on scales that made human history look like an instant. The satellite network was not static, but adaptive, continuously reconfiguring itself in response to changing conditions. The individual units could apparently be manufactured or decomposed as needed, allowing the system to scale up or down based on requirements. And the network was capable of interstellar communication, broadcasting and receiving signals from the nodes in the galactic map that 3I Atlas had revealed. Most significantly, analysis of the cylinder's surface encoding revealed fragments of what appeared to be historical records, observations of the solar system spanning millions of years, images of Earth at different geological epochs captured with such resolution that continental drift and climate changes were clearly visible. Records of astronomical events, asteroid impacts, ice ages, volcanic eruptions, all documented with scientific precision. They've been watching us for millions of years, Yamamoto stated, his voice quiet with awe and unease. Long before we evolved, long before anything recognizably human walked the Earth, they were here, observing and recording. We thought we were making first contact, but from their perspective, they've known about us forever. We're the newcomers to a conversation that's been going on since before we existed. Dr. Chen found this revelation profoundly disturbing. The idea that humanity's entire existence had been observed, catalogued, studied by external intelligences, it inverted everything humans had believed about their significance and autonomy. We hadn't discovered them. They had always known about us. Every step of human evolution, every moment of our history, had potentially been watched and recorded by entities whose purposes and judgments remained completely opaque. It raises questions about free will and destiny, Chen mused during a late-night conversation with close colleagues. If they've been watching for millions of years, do they already know how our story ends? Have they seen civilizations like ours rise and fall before? And if so, why bother warning us about the threat? Why provide technologies to help us survive if they already know whether we'll make it or not? Webb, participating via video link, offered his perspective. Maybe that's the point. Maybe the warning and the technology aren't about ensuring our survival. They're about testing whether we're capable of ensuring it ourselves. They've given us the tools and the information. What we do with it determines whether we're worth preserving as part of whatever larger cosmic community or purpose they represent. The implications of this test hypothesis spread through the research community and beyond. If humanity was being evaluated, what were the criteria? What did these ancient intelligences consider valuable or important? And what happened to civilizations that failed their test? Some of the data from the cylinder's surface provided disturbing hints. There were records of other worlds, other civilizations that had been monitored over geological timescales. And for some of those civilizations, the records ended abruptly. No slow decline, no gradual fading, but sudden termination at specific points in their development. Had those civilizations been destroyed by the radiation wave that 3I Atlas warned about? Or had they failed some kind of evaluation and been deemed unworthy of preservation? The data was ambiguous, open to multiple interpretations, but the pattern was there. Not all civilizations that developed technology survived to become spacefarers. Some ended, and their ending was noted in the records without apparent emotion or judgment. As summer 2028 arrived, the world grappled with these revelations. The initial excitement about contact with alien intelligence had matured into something more complex, an understanding that humanity was a latecomer to a cosmos that had been organized and managed by intelligences far older and more capable than us. We were not explorers discovering a virgin universe, but provincial newcomers being introduced to systems and structures that had existed for eons. Religious communities struggled with theological implications. If Earth had been watched for millions of years, what did that mean for concepts of divine providence or human special creation? Some traditions adapted by proposing that the ancient watchers were themselves part of divine plan, angels or servants of higher purposes. Others fragmented, unable to reconcile traditional beliefs with the new reality. Educational systems worldwide began teaching children about the Sentinel mission and its discoveries. A generation was growing up that would never know the innocent belief that humanity was alone or unobserved. They would understand from childhood that we lived in a monitored cosmos, that our actions had audiences, and that our future might depend on demonstrating worthiness to intelligences we barely understood. The consortium continued its work, but the research agenda had shifted. Understanding the threat and preparing defenses remained priorities, but increasingly, resources were devoted to trying to understand the watchers themselves. What did they want? What were they protecting? And could humanity establish genuine communication and relationship with them, rather than remaining passive subjects of distant observation? Petrov made another significant breakthrough in August 2028. She had been analyzing the fragments of the equation that 3I Atlas had transmitted, the one suggesting that consciousness could affect space-time. When combined with data from Sentinel's observations of how the cylinder manipulated space-time through rotation and field generation, a pattern emerged. Consciousness isn't just aware of reality, Petrov explained in a presentation that would become one of the most watched scientific lectures in history. According to this framework, consciousness participates in creating reality at a fundamental level. The watchers aren't separate from the universe they observe. They're entangled with it, their observations and intentions actually shaping the structure of space-time around them. She displayed complex equations showing how directed attention and intention, if sufficiently organized and focused, could create measurable effects on quantum states and even on larger-scale phenomena. It suggested that the technologies demonstrated by 3I Atlas and the cylinder weren't purely mechanical. They incorporated consciousness itself as a fundamental operating principle. This is why they're so far beyond us, Petrov continued. It's not just that their technology is more advanced, it's that they understand and can manipulate the relationship between mind and matter in ways we're only beginning to glimpse. They can think things into existence in a very literal sense. The universe responds to their intentions because they understand how to align their consciousness with the underlying quantum structure of reality. If this interpretation was correct, and it remained highly speculative and controversial, then the gap between humanity and the Watchers was even wider than previously thought. It wasn't just a matter of learning their technologies or understanding their science. It would require a fundamental evolution in human consciousness itself, a transformation in how humans related to reality at the deepest levels. Dr. Rahman's teams began exploring whether the technologies from the 3I Atlas blueprints might be designed to facilitate exactly that transformation. Perhaps the devices weren't just tools to be used mechanically, but instruments for training human consciousness to operate in new modes, to perceive and manipulate reality in ways that would bring us closer to the level of the Watchers. It would make sense, Rahman argued. If they're testing whether we're worthy of survival and integration into their cosmic community, they wouldn't just want to see if we could copy their technology. They'd want to see if we could transcend our current limitations, evolve beyond our provincial consciousness, become something more than we currently are. The tools they've given us might be means to that end. As 2028 drew to a close, Dr. Chen took stock of how far humanity had come and how far it still had to go. 4 years had passed since 3I Atlas's arrival, 4 years of unprecedented discovery and unsettling revelation. Sentinel had made contact with the hidden object and returned with data that would occupy researchers for decades. Technologies derived from alien blueprints were being cautiously developed and tested, and humanity was slowly, painfully, beginning to understand its place in a cosmos far stranger and more populous than anyone had imagined. But 41 years remained until the predicted arrival of the threat. 41 years to transform human civilization, to develop technologies barely understood, to potentially evolve human consciousness itself into something capable of operating at cosmic scales. The timeline seemed impossibly short for such ambitious goals. "We're not going to make it," Chen admitted to herself in a moment of late-night despair, alone in her office with only the stars for company. "Not all of us, anyway. Even if everything works perfectly, even if every technology functions as intended, even if the defensive systems can be deployed in time, we won't be able to protect everyone. There will be choices, sacrifices, losses that will haunt us forever." She looked up at the night sky, visible through her office window, and wondered if the Watchers ever felt such despair. Did they, in their vast wisdom and capability, still know the pain of insufficient resources and impossible choices? Or had they transcended such limitations, operating at levels where every threatened civilization could be saved, every consciousness preserved? The data suggested otherwise. The records on the cylinder showed civilizations that had ended. The Watchers had observed those endings and recorded them, but apparently not prevented them. Whatever criteria they used for intervention, not every civilization met them. Not every species was deemed worthy of salvation. The question that haunted Chen, that she couldn't escape no matter how hard she worked or how much she learned, was simple and terrible. Had humanity already been judged? When 3I Atlas departed, when the cylinder activated in response to Sentinel's approach, were those signs that we had passed some kind of test? Or were they simply neutral responses with the real evaluation still ahead? She didn't know. None of them knew, and that uncertainty would color every decision, every plan, every hope for the next 4 decades as humanity prepared to face whatever was coming. The cosmos watched and waited, silent and patient, keeping its own counsel, and Earth spun through space, carrying billions of human lives toward a rendezvous with destiny that grew closer with every passing day. 41 years to become something more than they currently were, or to fail and join the anonymous list of civilizations whose records ended abruptly in the vast archives maintained by the Watchers. The clock was ticking, and there was so much still to do. The decade that followed Sentinel's encounter with the cylinder would come to be known as the Years of Transformation. Humanity, confronted with irrefutable evidence of its cosmic insignificance and simultaneous cosmic significance, underwent changes that touched every aspect of civilization. But these changes were neither uniform nor universally positive. The species that had once wondered if it was alone now struggled with the knowledge that it had always been watched, always been known, and might soon be tested in ways that would determine its very survival. Dr. Sarah Chen stood before the United Nations General Assembly on January 15, 2030, delivering a report that represented 6 years of intensive research by thousands of scientists across dozens of nations. The consortium had compiled everything humanity had learned from 3I Atlas and Sentinel into a comprehensive assessment of the threat, the available defenses, and the timeline for deployment. The numbers were sobering. To protect Earth's major population centers, home to approximately 4.7 billion people, would require the construction and deployment of 23,000 of the defensive field generators derived from the alien blueprints. Each generator took approximately 18 months to manufacture with current techniques, required materials that existed in limited global supply, and consumed energy during operation equivalent to a medium-sized city. Current production capacity stood at approximately 400 units per year across all manufacturing facilities worldwide. At that rate, achieving the necessary coverage would take 57 years, 16 years beyond the deadline when the radiation wave was predicted to arrive. "The mathematics are unforgiving," Chen stated, her voice echoing through the vast assembly hall. "Even with aggressive scaling of production facilities, even with unprecedented international cooperation and resource allocation, we cannot protect everyone. We face a moral calculus that no generation of humans has ever confronted. We must choose who survives." The silence that followed was absolute. 2,000 diplomats, officials, and observers sat frozen, confronting a truth that governments had known but had not publicly acknowledged. The defensive preparations would necessarily be selective. Billions of humans, along with uncountable other species in Earth's ecosystems, would remain unprotected when and if the threat arrived. The political firestorm that followed Chen's testimony was immediate and intense. Nations demanded priority protection for their populations. Debates raged about the criteria for selection. Should it be based on population density, technological capability, cultural significance, genetic diversity, or simple geographic distribution? Every proposal sparked outrage from those who would be excluded. Dr. Marcus Webb, who had spent years warning about the dangers of blindly trusting the alien warning, found himself in an uncomfortable position. His cautious skepticism had been vindicated in one sense. Humanity had indeed become dependent on alien technology that it barely understood. But the alternative he'd advocated, ignoring the warning and continuing as before, now seemed irresponsible in the face of mounting evidence. "I was wrong about some things and right about others," Webb admitted in a widely viewed interview. "The watchers are real, the threat appears genuine, and the technology they've provided does work. But I was right that this situation has fundamentally compromised our autonomy. We're now making decisions, life and death decisions for billions, based on information from entities whose motivations we don't understand. That's a dangerous position for any civilization." Dr. Jennifer Morrison had moved on from the Sentinel mission to lead a new initiative, the Deep Archive Project. If the defensive systems failed, if the radiation wave proved more destructive than anticipated, humanity needed a backup plan. Morrison's project aimed to create hardened repositories deep underground and in lunar craters, sealed vaults containing genetic samples, cultural records, technical knowledge, everything necessary to rebuild human civilization if surface populations were decimated. "We're building time capsules for a future we hope never comes," Morrison explained, touring one of the excavation sites being carved into bedrock 3 kilometers below the surface in Norway. "But hope isn't a strategy. If the worst happens, if the defenses fail or prove inadequate, these archives might be what allows some remnant of humanity to survive and eventually recover." The archive sites were deliberately distributed across the globe and off-world, ensuring that no single catastrophe could destroy all of them. Each facility was designed to remain viable for at least 10,000 years, with power systems, environmental controls, and data storage media engineered for extreme longevity. Some sites were purely automated. Others included provisions for small populations of humans to enter suspended animation, ready to emerge decades or centuries later into whatever world awaited them. The project was controversial. Critics argued that resources spent on archive facilities would be better used increasing production of defensive systems. Others objected to the selection criteria for which humans would be offered places in the suspended animation program, a separate and even more fraught version of the triage problem that plagued the defensive deployment planning. Meanwhile, Dr. Kenji Yamamoto's continued analysis of the data from the cylinder's surface revealed something that fundamentally altered the understanding of the Watcher's network. The historical records encoded on the cylinder didn't just show observations of Earth, they showed interventions. Subtle ones, barely detectable, but present in the data if you knew how to look. Asteroid trajectories altered slightly, diverting objects that would have struck Earth during critical periods in the evolution of complex life. Solar radiation patterns showing anomalies during epochs when Earth's magnetic field was weak, as if something had provided additional shielding, even atmospheric composition showing unexplained buffering during periods of extreme volcanic activity that should have triggered runaway greenhouse effects. "They've been gardening us," Yamamoto stated, presenting his findings to a closed session of senior researchers. For hundreds of millions of years, subtle interventions maintaining conditions suitable for complex life to evolve. We didn't develop in isolation, we developed in a carefully tended environment. Earth is not a wilderness, it's a garden, and we're the crop they've been cultivating. The implications were profound and disturbing. If the Watchers had been actively managing Earth's environment for geological timescales, then humanity's existence was not an accident or an inevitability. It was a product of deliberate cultivation, and that raised the question, cultivation for what purpose? Dr. Elena Petrov, working with the quantum-encoded data from 3I Atlas, believed she had found part of the answer. Hidden in the deepest layers of the transmitted information was what appeared to be a catalog of different civilizations, classified according to criteria that remained partially opaque. But one classification was clear. Some civilizations were marked as compatible, while others were designated incompatible. "It's selection," Petrov explained, her voice tight with the implications of what she was describing. "The Watchers are cultivating compatible civilizations across the galaxy. The interventions, the gardening, the careful monitoring, it's all aimed at producing species and cultures that fit certain criteria. And those that don't fit," she paused, pulling up data showing civilizations whose records ended abruptly. "Those are allowed to fail." But compatible with what? The data didn't explicitly state the purpose or goal of this galactic-scale cultivation program. Theories proliferated. Perhaps the Watchers were preparing civilizations to join some kind of cosmic community or collective. Perhaps they were creating a distributed intelligence network spanning the galaxy. Or perhaps the purpose was something humans couldn't yet conceive, operating on principles and for goals that required a level of consciousness humanity had not yet achieved. Darlisa Rahman's teams made breakthrough after breakthrough in understanding and replicating the alien technologies. By 2032, they had achieved major advances in several areas. The zero-point energy generators were now in mass production, providing clean, unlimited power that was beginning to replace conventional energy sources in some applications. The space-time manipulation propulsion systems were being incorporated into a new generation of spacecraft that could travel through the solar system in a fraction of the time required by conventional rockets. But the most significant achievement was in understanding the consciousness interface technologies that Petrov had theorized about. Rahman's teams had built devices that appeared to amplify and focus human consciousness, allowing trained operators to affect quantum systems through directed intention alone. "We're not talking about magic or mysticism," Rahman clarified for the skeptics. "This is physics. Quantum mechanics at scales we're only beginning to understand. Consciousness appears to be a fundamental feature of reality, not an emergent property of complexity. These devices don't give you supernatural powers. They allow your consciousness to interact with reality in ways that are natural but normally too weak to detect or use purposefully. The military applications were immediately obvious, and several nations attempted to classify and weaponize the consciousness interface research. But Raman and her colleagues had anticipated this and taken steps to ensure the technology remained in civilian hands and under international oversight. They published their findings openly, making the basic principles available to researchers worldwide. Weaponizing consciousness would be the worst possible misuse of this knowledge, Raman argued in heated debates with military officials. If the Watchers are evaluating us, judging whether we're compatible with whatever cosmic community they represent, then turning consciousness interface technology into weapons would be the clearest possible signal that we've failed, that we're not ready, not worthy, not compatible. But not everyone agreed. Factions within several governments argued that preparing for the worst included preparing for the possibility that the Watchers themselves were a threat, that the entire scenario, the warning, the technology, the monitoring, was the elaborate deception designed to make humanity vulnerable. These factions pursued independent research programs, developing technologies that could potentially be used against the Watchers' systems. The fractures in international cooperation that had appeared in the earlier years widened into chasms. By 2033, 3 distinct blocs had emerged with fundamentally different approaches to the situation. The cooperative bloc, led by the European Union, Japan, and several other nations, committed to following the consortium's recommendations, deploying defensive systems according to an ethical framework that prioritized human rights and international equity. They rejected weaponization of the alien technology and pursued open scientific cooperation. The sovereign bloc, including the United States, Russia, and China, maintained participation in international efforts, but also pursued independent programs that prioritized national security and sovereignty. They developed their own defensive systems, conducted classified research into military applications, and maintained strategic ambiguity about their capabilities and intentions. The rejection bloc, a smaller coalition of nations primarily in the developing world, argued that the entire alien contact scenario was a manipulation by advanced nations to justify increased military spending and authoritarian control. They rejected the alien warning as unverifiable, refused to participate in defensive preparations they saw as wasteful, and advocated for continued focus on terrestrial problems like poverty, disease, and climate change. Dr. Chen watched this fragmentation with despair. The unity of purpose that had characterized the early response to 3I Atlas had completely dissolved. Instead of coming together to face a common threat, humanity was splitting apart, each faction pursuing its own agenda based on its own interpretation of ambiguous and incomplete information. This might be the actual test, Chen mused in a late-night conversation with close colleagues. Not whether we can build the technology or understand the science, but whether we can cooperate, transcend our divisions, work together as a unified species rather than as competing tribes. And by that measure, we're failing spectacularly. The situation deteriorated further in 2034 when intelligence services detected that several nations had begun constructing large-scale facilities in deep space beyond Earth orbit. Telescope observations revealed massive structures being assembled at the Lagrange points and in lunar orbit. The official explanation was that these were manufacturing facilities for defensive systems, taking advantage of microgravity and abundant solar power. But analysts noted that the designs included features inconsistent with pure manufacturing: weapons ports, high-energy systems, configurations that looked more like military installations than industrial facilities. The space race that had begun as a cooperative effort to understand and prepare for the alien threat was transforming into an arms race, with nations positioning assets for potential conflict with each other, or possibly with the Watchers themselves. Dr. Yamamoto made another disturbing discovery in the cylinder's encoded data. Buried in the historical records were detailed observations of human civilization's recent development, not just the general environmental observations spanning millions of years, but specific, high-resolution monitoring of human activity over the past century. Images of cities, analysis of radio and internet transmissions, cataloging of technological developments. The watchers knew everything about contemporary human civilization. They had watched the world wars, the Cold War, the development of nuclear weapons, the space race, the information revolution. Every human achievement and atrocity had been observed and recorded. The idea that humanity was being evaluated wasn't speculation. It was confirmed fact. The only question was whether the evaluation was ongoing or had already been completed, whether the verdict was still pending or had already been rendered. "If they've been watching us this closely," Yamamoto stated, presenting his findings to a somber assembly of senior researchers, "then they know about the fragmentation, the weapons development, the space facilities being built. They're watching us tear ourselves apart when we should be uniting, and they're recording it all, adding it to their assessment of whether we're compatible with their plans." The revelation sparked another wave of debate. Some argued that humanity should be transparent, accepting that the watchers would see everything regardless, and hoping that honesty and authenticity would count in our favor. Others advocated for careful management of the information available to the watchers, attempting to present humanity in the best possible light. But Dr. Marcus Webb pointed out the futility of such efforts. "You can't manage the impression you make on beings who've been observing you for millions of years and have access to monitoring technology we can barely conceive of. They see everything, our best and our worst, our cooperation and our conflicts, our nobility and our pettiness. All we can do is be what we are and hope that's sufficient." As 2035 arrived, the countdown to the predicted threat stood at 36 years. More than a decade had passed since 3I Atlas's initial visit, and humanity had made remarkable progress in some areas while backsliding dangerously in others. Production of defensive systems had ramped up significantly. Over 6,000 units were now operational, protecting approximately 900 million people in designated priority zones. But the protective coverage was unevenly distributed, largely concentrated in wealthy nations and major urban centers in the developed world. Vast regions, including most of Africa, Central Asia, and parts of South America, remained completely unprotected. The moral calculus that Chen had warned about was being resolved not through ethical deliberation, but through the raw mechanics of power and economics. Dr. Morrison's Deep Archive project had completed 14 major facilities and was on track to complete 36 by 2040. Each facility contained genetic samples from millions of species, cultural records from thousands of human societies, and comprehensive technical knowledge spanning the entire history of human science and engineering. If catastrophe struck, the archives would preserve the essentials of Earth's biodiversity and human civilization for whatever future might come. But the archives faced challenges beyond the merely technical. Who decided which cultural records were included? Which languages, which histories, which perspectives would be preserved? The selection process became a battleground for competing visions of humanity, with every excluded group arguing that their stories and knowledge were essential and irreplaceable. We're trying to preserve all of human civilization in facilities that, combined, have less storage capacity than a large modern data center, Morrison explained, frustrated by the impossible constraints. Choices have to be made. Things will be lost. We're doing our best to be comprehensive and equitable, but perfect preservation is physically impossible. Something of humanity will survive, but it won't be everything. Dr. Rahman achieved what many considered her greatest breakthrough in March 2036. Her teams had been working on reverse engineering the temporal manipulation technology from the 3I Atlas blueprints, the mysterious devices that appeared to create localized time distortions. After 8 years of effort, they finally achieved a stable, reproducible effect. The device, when activated, created a bubble of altered time flow approximately 10 meters in radius. Within the bubble, time passed at a different rate than in the surrounding space. The initial prototype created a dilation factor of 1.5. For every hour that passed outside the bubble, 90 minutes passed inside. The effect was modest, but measurable and confirmed. "This changes everything," Rahman announced, presenting her findings to the consortium leadership. "If we can scale up this technology, create larger bubbles with greater time dilation factors, we can do things that were previously impossible. Manufacture defensive systems faster by conducting the work in accelerated time. Protect populations by putting them in time-dilated shelters where decades pass outside while only months pass inside. Even send ships away from Earth at conventional speeds and use time dilation to make the journey survivable for the crew." But the technology also had darker applications. Military strategists immediately recognized that temporal weapons, devices that could trap enemies in time loops, age targets rapidly, or create temporal barriers, would be devastatingly effective. And several nations began classified programs to explore exactly those possibilities, despite international protests and condemnation. The consortium faced a crisis of purpose. The technologies they had decoded and developed, intended to save humanity from an external threat, were being weaponized for internal conflicts. The knowledge that might preserve civilization was simultaneously being used in ways that could destroy it. Chen and her colleagues debated whether to cease publishing their findings, to restrict access to the most dangerous technologies, or to double down on openness in the hope that transparency would limit misuse. "We're in an more impossible position," Chen stated in a tense meeting with the consortium's ethics board. "If we restrict access to knowledge, we're accused of creating a scientific elite that controls humanity's future. If we publish openly, we're accused of enabling weapons development and dangerous experimentation. There's no path forward that doesn't involve terrible trade-offs and outcomes we can't control." Meanwhile, in the outer solar system, the cylinder remained active. Its rotation continued at the accelerated rate established after Sentinel's visit, and the gravitational field it generated had stabilized into a configuration that appeared to be a template or prototype for a much larger defensive structure. Analysis suggested that the cylinder could, if needed, generate a field large enough to encompass Earth's entire orbit, but only if it received additional energy from external sources. Several research teams proposed sending another mission to the cylinder, this time with the intention of establishing communication or even cooperation with whatever intelligence controlled it. But the logistics were daunting, and the political situation made international cooperation on such a mission nearly impossible. The fragmented blocks couldn't agree on mission parameters, crew selection, or even whether the mission should be attempted at all. Dr. Petrov made her final major discovery in August 2037. She had been working on decoding the deepest layers of the quantum encoded data from 3I Atlas, layers that had remained inaccessible despite years of effort. A breakthrough in quantum computing techniques finally allowed her team to access what appeared to be the final, most deeply encrypted information in the dataset. What they found was a message, direct and unambiguous, addressed not to humanity as a whole, but to those individuals who had the capability to decode it. The message was brief. "You have been evaluated across multiple criteria spanning technological capability, social coherence, ethical reasoning, and consciousness development. Your species shows potential, but remains fractured and prone to self-destructive behaviors. The defensive technologies provided are necessary but not sufficient. Survival requires transcendence, not of the threat, but of your current limitations as a species. You have 35 years. Use them wisely. The choice of what you become is yours, but know that the cosmos has no patience for species that cannot transcend their origins. We will observe. We will not intervene again. The outcome is yours to determine." The message was signed with a symbol, a geometric pattern that matched designs seen on both 3I Atlas and the cylinder. It was authentically from the Watchers, a direct communication that provided more clarity than anything humanity had received before. Chen read and reread the message, feeling its weight settle on her shoulders like a physical burden. The Watchers were not rescuers. They were not threats. They were observers, evaluators, gardeners, tending a cosmic crop. They had provided tools and warnings, but the actual work of transformation, of becoming something capable of surviving in a dangerous cosmos, was humanity's responsibility alone. "35 years," she repeated to herself. 35 years to transcend our limitations, to become something more than we've ever been. Is that even possible? Can a species change that fundamentally in such a short time? Dr. Webb, reviewing the message, offered a different perspective. Maybe the time constraint is the point. Maybe species that can't transform rapidly when faced with existential pressure are exactly the ones that shouldn't survive. The cosmos is dynamic, threats are constant, and adaptation is essential. If we can't meet this challenge, then perhaps we're not compatible with the reality the Watchers are trying to cultivate. The message was kept classified for 3 months while leadership debated how and whether to release it to the public. Eventually, Chen made the decision to publish it openly, arguing that humanity deserved to know what the Watchers had communicated, even if that knowledge was difficult and the implications unclear. The public reaction was complex and varied. Some found the message inspiring, a challenge to rise to. Religious communities incorporated it into theological frameworks, seeing it as a test of faith or a call to spiritual evolution. Philosophers debated what transcendence might mean in practical terms. Was it technological, psychological, social, spiritual, or some combination? But others found the message threatening or insulting. Rejection bloc nations argued that it confirmed their suspicions. The entire scenario was a manipulation designed to force humanity to change according to external criteria rather than developing according to its own values and timelines. Protests erupted in major cities, with demonstrators demanding that governments reject the alien ultimatum and focus on terrestrial concerns. The fragmentation of humanity accelerated. By 2038, the 3 blocs had hardened into distinct political and ideological camps, each pursuing its own vision of how to respond to the situation. The cooperative bloc focused on ethical deployment of defensive systems and conscious evolution programs aimed at developing the kind of consciousness interface capabilities Raman had demonstrated. The sovereign bloc prioritized technological advancement and strategic positioning, building capabilities that could be used defensively or offensively as circumstances required. The rejection bloc advocated for resistance to the entire alien agenda, arguing that humanity should remain true to its current nature rather than transforming itself to meet external standards. Dr. Morrison, observing the deepening divisions from her position overseeing the Deep Archive project, made a difficult decision. She expanded the project's scope beyond mere data preservation. Each archive facility would now include suspended animation capabilities for much larger populations, not just a few hundred but potentially thousands at each site. If civilization collapsed, if the divisions tore society apart before the radiation wave even arrived, these archive facilities could serve as refuge for whoever managed to reach them. We're preparing for the possibility that humanity destroys itself before the external threat even arrives, Morrison stated bluntly in a meeting with her staff. The radiation wave might be irrelevant if we've already torn civilization apart through our own conflicts and inability to cooperate. These facilities need to be able to preserve not just data and genetic samples, but viable populations that could rebuild afterward. The realization that internal collapse was as significant a threat as the external radiation wave spread through the research community. Studies and simulations suggested that societal breakdown could occur much sooner than 35 years if current trends continued. Resource conflicts over access to defensive systems, ideological battles over how to respond to the Watchers, economic disruptions from rapid technological change. All of these pressures were pushing human civilization toward fragmentation and potential collapse. Dr. Yamamoto, analyzing patterns in the cylinder's historical records, found examples of civilizations that had indeed destroyed themselves before external threats could arrive. The patterns were recognizable. Initial unity in response to the revelation of external threats, followed by fragmentation as different factions developed competing visions of response, escalating into conflicts that consumed resources and attention that should have been devoted to the actual threat. We're following a known failure mode, Yamamoto reported, his voice heavy with the weight of what he was describing. Other civilizations have been where we are now, faced with similar choices, and they chose wrong. They turned on each other instead of facing outward together. And those civilizations ended, not because the external threat destroyed them, but because they destroyed themselves. The Watchers observed and recorded, but did not intervene. And they won't intervene for us either. We have to choose. Choose cooperation over conflict, choose unity over division, choose transformation over stagnation. Chen took Yamamoto's findings and turned them into a final plea to the United Nations in November 2038. She presented the data showing how other civilizations had failed, the patterns of self-destruction, the terrible final entries in the Watchers' records where thriving societies simply stopped existing, consumed by internal conflicts that made them unable to face external challenges. We know how this story ends if we continue on our current path, Chen stated, her voice carrying the authority of someone who had devoted 14 years to understanding the situation. We've seen it in the data. Other civilizations have stood where we stand now, and they made choices that led to their extinction, not because they lacked technology or knowledge, but because they lacked wisdom. They couldn't transcend their divisions. They couldn't see beyond their immediate conflicts to the larger existential issues. And they died. And their deaths were recorded dispassionately in archives maintained by beings who observed but did not intervene. She paused, looking out at the assembled representatives, seeing the same divisions and conflicts that had plagued humanity throughout the crisis. The Watchers are not going to save us. They've given us tools and warnings, but the actual work of survival is ours alone. We have 33 years left, 33 years to become something we've never been, a truly unified species, capable of acting coherently in the face of existential threat. Is that possible? I don't know, but I know the alternative is unacceptable. We either transcend our current limitations or we join the long list of civilizations that couldn't. The speech was broadcast worldwide, watched by billions. Its impact was significant, but ultimately insufficient to reverse the deepening divisions. The blocs remained committed to their divergent approaches, and the fragmentation continued. As 2040 approached, marking 16 years since 3I Atlas's arrival, humanity found itself in a strange position. Remarkable progress had been made in some areas. Over 14,000 defensive systems were now operational, protecting approximately 2 billion people. Consciousness interface technologies were advancing rapidly, with thousands of trained operators now capable of affecting quantum systems through directed intention. Temporal manipulation technology was approaching the point where it could be deployed at meaningful scales. But socially and politically, humanity was more divided than at any point in recent history. The three blocs had evolved into what amounted to separate civilizations with different values, different technological priorities, and different visions of what humanity should become. Communication and cooperation between blocs had dwindled to minimal levels, and each bloc viewed the others with suspicion and hostility, seeing them as obstacles or threats rather than partners in a common effort. Dr. Chen, now in her 60s, looked back on 16 years of effort with mixed feelings. Remarkable scientific achievements had been made. Technologies that would have seemed like magic at the start of the crisis were now operational realities. Humanity had touched the boundaries of cosmic civilization and brought back knowledge that transformed understanding of physics, consciousness, and reality itself. But the social and political failures were equally remarkable. A species that should have unified in the face of external threat had instead fractured into competing factions. Resources that should have been devoted to collective survival were being squandered on internal conflicts. And the clock continued its inexorable countdown toward a deadline that would not be moved or negotiated. We've learned so much and understood so little, Chen reflected in a conversation with the few colleagues who remained from the early days of the crisis. We can manipulate space-time and interface consciousness with quantum fields, but we can't figure out how to cooperate with each other. We've glimpsed the cosmic community that might await us if we survive, but we can't transcend the petty divisions that might prevent us from reaching it. Dr. Rahman, still leading technological development efforts, remained more optimistic. We have 31 years left. That's an entire generation. Children born today will be adults when the deadline arrives. Maybe they'll succeed where we've failed. Maybe growing up in a world where cosmic context is normal, where alien contact is historical fact rather than science fiction, will give them perspectives we couldn't achieve. The transcendence the Watchers called for might not happen in our generation, but it could happen in the next. Dr. Morrison, observing from her position with the Deep Archive project, was less hopeful. Every year that passes without fundamental change in our approach makes the challenge harder. The defensive systems we're building are based on technology from 16 years ago, the Watchers technology. But we're not advancing beyond it, not developing our own solutions. We're still dependent on them, still following paths they laid out for us. That's not transcendence. That's sophisticated mimicry at best. Dr. Petrov, having decoded the final message from the Watchers, spent her time analyzing what transcendence might actually mean in practical terms. Her research suggested that the Watchers weren't asking for technological advancement. Humanity had demonstrated sufficient capability in that area. They were asking for something more fundamental, a transformation of consciousness itself, an evolution in how humans related to reality and to each other. Technology is easy, Petrov explained. Give any reasonably intelligent species enough time and resources, and they'll develop sophisticated technology. But consciousness is hard. Learning to think and act as a unified species, transcending tribalism and competition, operating from a place of wisdom rather than fear, that's the real challenge, and it's the challenge we're failing. As 2040 arrived, Dr. Chen made a decision. She stepped down from her position as director of the Atlas Research Consortium, passing leadership to a younger generation of researchers. At 62, after 16 years at the center of humanity's response to the greatest crisis in its history, she was exhausted and needed to step back. But before she left, she recorded a final message, addressed not to her contemporaries but to the future, to whatever humans might exist when the deadline finally arrived in 2071. To whoever watches this in the future, Chen began, her face showing the lines and weariness of 16 years, bearing impossible responsibilities. I don't know if you're watching this in a world that survived or in the aftermath of catastrophe. I don't know if humanity found the transcendence the Watchers called for, or if we remained trapped in our limitations until the end. What I can tell you is that we tried. Not always wisely, not always together, but we tried. We decoded alien technologies that seemed like magic. We built defensive systems that can manipulate space-time. We learned that consciousness itself can be a force acting on reality. We discovered that we've been watched for millions of years by intelligences that garden civilizations across the galaxy. And we struggled with what to do with that knowledge. We fought with each other when we should have united. We pursued national interests when we should have prioritized species survival. We weaponized technologies that should have been used purely for defense. We failed in many ways, but we also succeeded in others. We didn't give up. We didn't ignore the warning or dismiss the evidence. We didn't pretend the crisis wasn't real just because accepting it was difficult. We faced the truth, even when the truth was terrifying and overwhelming. If you're watching this, you carry that legacy. Our successes and our failures, both. Learn from both. The Watchers are still out there, still observing, still recording. They gave us tools and warnings, but the choice of what we became was ours to make. I hope we chose wisely. I hope you exist in a world where we found the transcendence they called for. But if not, if we failed and you're rebuilding from the ruins, know that the possibility still exists. The tools are there, the knowledge is preserved. The archives hold what you need to try again, to learn from our mistakes, to achieve what we couldn't. The cosmos has no patience for species that can't transcend their limitations, but it also offers infinite possibilities for those who can. Be worthy of those possibilities. Become what we struggled to become. Reach for the stars, not just physically, but consciously and spiritually. The Watchers are waiting. The cosmos is watching. Show them, show yourselves, what humanity can become when it truly tries. Chen ended the recording and authorized its distribution to all the Deep Archive facilities. Whatever future emerged from the next 31 years Whoever survived to see 21, they would have this message, this record of humanity at its most challenged moment. She left the consortium headquarters for the last time on a cold January evening, walking out into the Swiss night under stars that no longer seemed quite so distant or indifferent. Somewhere among those points of light were the watchers, observers who had tended Earth for millions of years and who were now waiting to see if their latest crop would flourish or fail. 31 years remained. 31 years for humanity to become something it had never been. 31 years to transcend divisions that had characterized the entire span of human history. 31 years to prove worthy of survival in a cosmos that offered no guarantees and no second chances. The countdown continued. The clock was ticking. And everything that humanity had been, everything it might become, hung in the balance. In the outer solar system, the cylinder spun in the darkness, its gravitational lighthouse broadcasting into the cosmic void. On Earth, billions of humans went about their lives, some preparing frantically for the deadline, others ignoring it, most somewhere in between, hoping, fearing, dreaming, and struggling with the weight of living in a monitored cosmos where nothing was certain except that change was coming. The story was not over. Perhaps it was only beginning. In 31 years, the radiation wave would arrive or it wouldn't. Humanity would survive or it wouldn't. The watchers would judge the species compatible with cosmic community, or they wouldn't. Everything was still possible, everything was still in question, and the answer would be written not in the stars but in the choices humans made in the time that remained. The cosmos watched and waited, and humanity, fractured but not yet broken, continued its long struggle toward a destination it could barely imagine. Transcendence or oblivion, apotheosis or extinction, cosmic citizenship or cosmic irrelevance. 31 years. The final countdown had begun.